Hey guys. Let's see, make sure that I can unmute everybody. There we go. So you should be able to speak. We'll keep the microphones open and active so you can talk. And
all right.
okay.
Can you hear me?
Yeah, I can hear you.
All right.
Okay. Yeah.
Hi, here we can hear me. This is Raj.
Yes, Raj. Hi, how are you doing?
Good.
I am going to. We're a little bit early, right? Yeah, I think so.
Yeah, a few minutes.
Yeah. We'll wait for people to come online. What I'll do is let everybody know that we have started. They can, join on time. So I'm going to grab the link we have here, send it out an email to everybody. That is my plan. Hello, Shiv. How are you doing? Hello, Shiv. How are you doing? Good to see you.
Nilesh, Happy New Year.
Hey, Happy New Year. Good to see you. So we have a couple of people already online, and we'll start at 4 o'clock. What I'm doing right now is grabbing that meeting invitation and sending it out to everybody in a group chat. We have a group chat. I'm typing that message. I have started the conference. Please join. Here we go. So I send that message out to Slack chat. I will also do the same thing in email and send everybody an email also. We have about 900 people. And so we want to make sure that everybody is received. I have not had the chance to talk one-on-one with at least a couple of people yet. So that is my concern. I am making sure that everybody gets online and then we proceed forward. So I am looking to share my screen first. There we go. So you should be able to see my screen right there. And I will now open my email and send out a notification to everybody telling that telling everybody we have joined, we have started. The session is starting. So I'm basically finding that email that I sent to everybody out. And where is that? Welcome mail. The welcome email is this one. And I'm going to all. Hello, everybody. I have started the video conference. Please join. Okay, so I'm sending that message out, and I think all of you should receive it. Okay, 1, 2, 3, 4, 5. I'm counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 people. Wow. Okay, so here we have a message going out to everybody, asking them to join. We will have people joining in. Hello, everybody. We have Alex, Eric. I'm unmuting everybody so that all of us can talk. We will keep microphones active so that people can basically ask a question anytime you feel like. That's the idea behind this. It is interactive, and so we will keep it like that. Unless one of you starts to make noise, then I will mute you, and then you have to unmute yourself. And so we'll do that, but I don't think that happens. I have tested audio quality with almost all of you one-on-one. And so the audio issues we have sorted out. There should not be any problem as such. And let's see, we have how many people? 1, 2, 3, 4, 5 people joined in already. That is sweet. And I would like to begin discussing a couple of things. For example, here in the Bootcamp section, if you go to the welcome button, you're looking at my screen, right? If you don't see my screen, my desktop, please tell me. And by the way, this video camera that I have set it up in a slightly different fashion. It doesn't point at my face, but at me in my direction, generally points at my direction. And if this looks weird to you, please tell me. And if that's the case, I will, make sure that I adjust my camera. I hope this is okay. So we have 7 people online, including me, and that's good. Okay, 2 more minutes. And there we go. We have more people coming in, and we have David. Hello, David. I think I am talking to David first time today. We never had a chance to connect, right, David? Are you there online?
I am, yes.
Yeah, hi. Good to see you. Good to see you and good to hear you. I
Yes.
made sure that you have access to the online website content, which is what I think I want to make sure that you do. And I think I'll also make sure that the audio is clean, which I don't see any problems. So, okay, let's begin. So please tell me that you have access to this welcome screen, which shows you the Bootcamp video conference and these links, the Cloud Technologies link, the Cloud DevOps link, and the Cloud Architecture link. Please tell me that you do have access. And if you don't have access, please tell me that also. Make sure that I want to make sure that you get access. The idea behind this content library is to give you enough content for you to do it on your own. And my recommendation would be that you forward, speed through, race through the whole content available to you already, even if I have not yet covered it. There is more content in the library here online than we can actually cover. And so therefore, I'm suggesting that, you please go forward. Start following along. There is this step-by-step sequence laid out. You please begin with the Cloud Technologies segment first. Don't begin with architecture. So, go follow the technologies first, and then DevOps, and then architecture. It's a step-by-step building plan. So we have to build accordingly. We'll go through like that. Now it is 4 o'clock almost. And so I welcome everybody. I want to say one thing which is required by law, which is to let everybody know that this session and all of our sessions will be always recorded. That means, your sound that you make, your picture that you show, your desktops, your faces on your video camera, they will be shared with other people. I just want you to realize that this session is being recorded, and that is required by law. So I just told you that. Having said, I am recording this because I want to give you a video, and that video will become available to you so that you can rewind and repeat. That's the primary idea behind this recording business. And the idea is that you can always, catch what did he say, and catch me, catch my mistakes. If you run into an issue, you call me, email me. We have a Slack chat channel. Use that. Use that to make sure that you actually gain benefit from this program. And I want that benefit to be in 3 different aspects. So the first one, build your skill set. Second one, build evidence. And third one, build your network of people that will work with you. We have more people joining in, I guess. That's what I'm getting alerted to. So I'm making sure that everybody is unmuted, because that is, I want to make sure that you can talk, that you can participate. Anytime you have a question, please speak up. And if I don't hear you, please call my number. You have my phone number. Call me if I don't listen to you. So anytime you need something, please speak. I want it to be interactive. That's the fundamental way of operations. So 3 things that I mentioned. Build skill, build evidence that you have the skill, and build your network that will vouch for your evidence, showing your evidence and prove that you have the skills that you want. Many of you actually want to make a transition in your career of some sorts. Some of you actually want to learn something new. Some of others who have experience but don't have the hands-on experience. So many of you have joined it for that purpose. So a variety of outcomes you want to accomplish. And we will help you individually, one-on-one. I will do that myself. Making sure that you get that goal that you have for yourself. With that, I would like to request the person who's generating noise. I can, by the way, detect who's making noise. I can mute you selectively if you like. And I will do that eventually once I detect the noise sources. Yeah. So, okay. I want to hear that everybody is able to access content here. So if there is somebody who does not have access, please tell me. And I would like to make sure that I give you access. So I want to get these things, the logistics parts moving forward, and make sure that you are ready for accessing the content. So begin here, the Cloud Technologies. Click on that one, scroll through.
This is Raj. I have a question.
Yes, hi.
You remember last week we looked at it, I could not log in because my account is already logged in from somewhere else.
Yes.
I thought you cleared my cache on your side.
Is it still persisting, that issue?
Yeah.
Please change the browser. I will reset your account. Don't worry. I'll reset that account and make sure that you can actually access. So I'm going to look for you as a user and reset your credentials. That should resolve that problem. So please try a different browser, different from the one that you were using last time. The one that I think worked last time was Chrome. So use that one.
Yeah, I'm logging on different computer. I just cleared my cache and everything. It's
different computer. That's good to know. That's the reason why. So, you know, the reason it locks you out, the reason it kicks you out is that the site is. So yes, if you want to, you know, crack jokes, it is better to crack that, you know, in the group, in our private group. So yes, jokes are welcome. But let everybody also smile at what you're saying, not just me. Otherwise, it looks very weird that I'm listening and, you know, at a one-on-one joke, which in a team meeting doesn't work. So crack jokes, welcome, but please do that in the 2017, whatever that thing is. Let crack it here. That's what you should do. And I'm going to now look for Raj and clear his sessions, so that you should be able to move forward with logging in on a different computer. If you log on to an account using multiple machines, that's the problem, that I had to reset your sessions because it prevents you from proceeding forward. And so I think, Raj, you should be taken care of. Now, having said, we have this sequence beginning from cloud technologies, and that's the idea. We will begin from here. There are some other logistic steps that I want to take care of. For example, there is a school account. So everybody will receive a Cloud Genius email. And if you haven't received that, I would like you to, you know, after this session, please contact me for a one-on-one. Maybe after 3 hours, end of the 3 hours, we should do that, spend some extra time in making sure that everybody gets access to some of the content, which we will create. Like I will write these things on this sheet of paper, and this is basically the OneNote notebook that, you know, I will be using to illustrate something. I will write something here, and this notebook gets synchronized with everybody. So it is it's a new product from Microsoft. It is called OneNote for Classes or Classroom. The product is called it's called classroom.microsoft.com, and that product we have access to for all of you. It has been set up. So you can actually receive my OneNote notebooks in your computer automatically. You will, you know, whatever I write here, you will receive that content automatically in your OneNote notebook because you are participating in the bootcamp as students in, so your names are showing on the left side, and through that, you will automatically receive whatever I write here. That's the idea. Now that will happen only if you have what I call a school email. That school email, some of you, I think I have received it already from me directly. I gave it to you, but others have not. So please talk to me at 7 p.m. Pacific time after we are done with this session today. We will work on that piece of, you know, some logistics elements, making sure that you get a school email address, you get access to this notebook and other content. We'll also have a place to store our videos at the end of this session. I think a couple of, you know, I think 1 or 2% just joined. I would like to remind everybody that this session is being recorded. And I would like to request a favor. The favor is that I would like you to please take a note of this icon that tells you that this session is actually getting recorded. So there should be some place in the screen that tells you that it is actually getting recorded. Do you see that? Do you see any notification?
Yes.
This is getting recorded. Okay.
Upper left-hand corner.
Okay, good. So somehow I'm not able to see it, and maybe it is my mistake. And so the idea is for you to please keep track on that, because if that recording stops, we have a problem. We don't have a video at the end of the session. So we want to make sure that it is actually getting recorded. And for chat, Sami is, Sami, the name is Sami, the way to pronounce it is Sami. Sami, please use the Slack chat, this chat that you just used. I don't monitor it. So that's great. Please use Slack chat in the group conversation we have here. That's where please chat. So it helps me. This recording is going to help you because it lets you receive that MP4 file at the end of the session. There is a specific method that I have been using to share that MP4 files with past participants. And that method is similar to the method that we have used to provide you with this virtual machine. You've seen this virtual machine. It is running on your machines right now. This Linux workstation, you have it already. You have received it through Resilio Sync. I will also use ResiliaSync the same way to send video recordings to you. It will be automatically pushed out to your computer without you having to download anything. As soon as I'm done with the session, the recording will get created and I will push it to you. So you will receive it without having to work for it, look for it. It just shows up in your computer. Some of you already have a method like this set up because you spoke to me one-on-one. For others, let us do it after this. I don't want to space time on this session and in the actual meat of the body of this discussion. So let's proceed forward with the actual content of the training as to what do we want to cover today. And so we have this outline kind of sort of mentioned, and I'll broadly follow this outline. However, I am okay with you interrupting me anytime. And so please remember to interrupt, because I love questions, because that's how I think all of us learn. There are some more chats coming into the Zoom chat, which I don't tend to monitor, and I think there is some, hold on, somebody just chatted there.
Nilesh, I still can't log in.
Hey, user logged in recently from a different location. Yeah, Raj, I think I'll fix that problem later on. Use Slack chat, not this Zoom chat. It makes my workflow difficult. I will don't worry about the website right now. I think I would stay focused on what I am describing, and I'll show it to you live, and you can always get to the site access later on. So don't worry, we are not using the site as such right now. Okay. Having said, let us create a new sheet of paper and discuss some of the core aspects as to what cloud computing is and how does it relate to what we are really trying to accomplish. And so let us begin with the fundamentals, like the fundamentals of what is cloud computing. Okay, I am going to mute somebody. Who's that? I'll take a note. Okay. So you know what? I'll just mute everybody. Please unmute when you want to talk. Unmute yourself. So you should be able to unmute when you feel like talking. I'm muting all of you. Having said, cloud computing, the core idea behind what this thing is, and what is it? What? That is the first question that comes to mind. Who defines it? What is the definition? Do you know who defines this word, cloud computing? What is cloud computing? Do you know? Is it you who defines it? Is it me? Do I get to define? Is it some college, some professor? By the way, I'm not a professor. I'm an industry person, just like you guys are. As you probably know, I am from Microsoft, more than a decade there. So people in the industry don't get to define it. In our country, NIST defines it. If you look at NIST, this institution, NIST.gov, this institution defines standards for us. And they have defined definition of cloud computing here. So if you search for cloud computing definition, you will find this particular document from NIST, not this one from PC Magazine, but from NIST. That standards body defines the final version of cloud computing in this document, which is available in this publication at this link. In this PDF file is a very good reading, especially when you're feeling sleepy in the night. That time you should read this long document. It can be boring. So I will zoom in on some very specific aspects of this document to point out where exactly the meat of this definition is. And it is right here. And that's pretty much it. These 3 lines in the PDF file define cloud computing succinctly. Let us read that. So I'm making sure that I zoom it properly. These 3 blue highlighted lines are the definition. The idea here is it is a model of using resources. Now, what is a resource? It can be, hard disk, a network, some kind of a CPU resource, any kind of compute resource that you have. You want to use it. It's a model of using that. That's a resource. If you define compute, storage, and network capabilities are the resources. We want to be able to use those resources in a fashion. Now that how to use them is what is defined here. Let's go read in detail, very specifically. It's a model for enabling what? Ubiquitous, convenient, on-demand network access to a shared pool of resources. It is a shared pool, meaning multiple people will share the same computer in some fashion. Multiple people will share the network. the storage, the CPU, the application, the services. Those are the resources that are being shared among multiple people, multiple as in more than one. More than one people are using some compute resources on demand, meaning whenever they feel like, and it's very convenient. All you need to do is click a button and you get access to it. And it is ubiquitous. You can be in Zimbabwe or in India or wherever you feel like, it is always there as long as you have access to the network. That's the idea. And so the scenario is that you are able to use these resources like I'm describing here. We have some, let me use a different sheet of paper that's probably faster than this. So it is kind of slow for me. I will switch my piece of paper and describe differently. So the idea that I'm describing is there is this thing called resource. And these are the users, multiple, more than one. And they want to access these resources. And so you can do this anytime you feel like, access these resources wherever you may be on the planet, like ubiquitous. As long as you have access to some kind of a network, you can access these resources. The resources themselves can be compute, as in specifically something like here, like processor, 4 gigahertz. That's the kind of CPU, compute. That's what I mean by compute. Memory resource. This is the 32 gigs of memory available. Like some disk resource, storage resource. See this disk here? There is a disk, 500 GB of SSD. There is external disk, another SSD, and there is another external disk. And so lots of disks. So there is disk-based access available. You also have network. Networks resources are available in this system. I'm just showing you a simple example of understanding what this thing is. But here is a bunch of networks that I have that are connected right now. One of them is Wi-Fi network, another Thunderbolt network, and a bunch of other networks. These are network resources. You also want to be able to use compute, storage. So compute, storage, and network. These are primary resources that are to be shared among users. And they will be able to access these compute, network, and storage resources on demand whenever they feel like. That's the kind of way of thinking about this definition, which is given here. Your PDF file describes that. You have access to ubiquitous, convenient, on-demand network access. So that's the core idea here. Now, they describe further. This model is composed of 5 characteristics, 3 service models, and 4 deployment models. Let's understand those things. Like, what are those things? So the 5 essential characteristics, they have to be, you have to meet these characteristics in order for us to call something a cloud. If you don't meet these characteristics, that thing is not a cloud. It is something else. So let us understand what is that, those 5 things, those 5 essential characteristics that make something into a cloud. That first characteristic is it has to be on demand. On demand as in I click a button, I get it. Not call somebody, an IT person, have them provision something. That's not on demand. No, it has to be click something, you do it. You run an API call, it happens for you. You don't have to call somebody on the phone and make these kind of old way of doing things. No, that is not cloud. If you have to call somebody to get a machine, that is not cloud. So that's one way to think about on demand. Whenever I feel like, I get it. Whenever I feel like getting rid of it, I just delete, destroy, completely get rid of the thing that I wanted. And that is on demand. So an example will be something like I go to this cloud. I'm just taking a simple cloud service from this company. I'm going to log into that service right now. Not this. Digital Ocean. Yeah, this cloud I prefer. I find them very useful. And so I'm going to quickly log into them. That I have an account there. So here is I'm typing my password. And I'm copying that password and typing it in and verifying. And there we have a cloud service available. So when I want to get a new machine, I will create a machine. They call it droplets, right? It's a fancy way of describing create a droplet in the digital ocean. It's marketing, but basically you're getting a computer. You're getting a computer running this operating system with that version of the operating system 1604, and you're getting a cheap machine, 512 MB RAM, 20 GB SSD, and 100,000 GB of transfer, disk activity, network activity. So that's the machine I want to get. I want to receive that machine in San Francisco, for example, or maybe Bangalore. I choose my location, and then I provide my key, and then I start, and that's it. I get a new computer ready, allocated to me, and I can now connect to it. And so it will take a minute to create the machine. You can see it actually spinning it up. A new full computer is starting up right now, and we should be able to connect to that machine comfortably without having to make a phone call with somebody. And that's the kind of on-demand concept that I'm describing here. It is the on-demand self-service. I want something, I get it. Broad network access. That's the second characteristic. As long as people have access to the internet, they can connect to that machine, like I described. They can get access to those resources that they want. The third one is resource pooling, meaning just like I created this machine right here in this cloud, you can also do that. It is being shared. In fact, if you look at under the hood, what this company does is something like, if you look at computer racks, you may have seen those kind of server racks, right? You may have seen pictures of these kind of things. For example, this lady standing next to an Intel machine set. Here is another picture. Lots of cables, lots of machines racked up on top of each other. Here's another one. You can see racks and racks of machines. Now, under the hood, what this company does, DigitalOcean, is they have a bunch of such racks in multiple locations. Those locations happen to be in these specific locations as they call out. This is just one example of some random cloud, right? I'm just picking on them for no reason. But they have chosen to build their data locations in New York. They have 3 of them. San Francisco, 2 of them. Amsterdam, 2 of them active. There are probably more. They're showing active, available 2 and 3. Singapore, 1. London, 1. Frankfurt, 1, like that. So multiple buildings they have in multiple locations, and that's where such machines are available for them. Now you can actually get to become my neighbor in this location where I just have created one new machine, which happens to be in Bangalore. I think I created the Bangalore location. You can also go and get a machine right next to me in a physical location. So this rack you might have, and so that particular rack where my machine will be running, you can be on that same machine side by side. It is shared between you and me. That's the concept of shared resource pooling. It is being shared by other people. And so that is a concern sometimes. So, people question, hey, is it safe to have my competition right next to me? That's a question we'll address those questions. Another thing, rapid elasticity. What does that mean? Elasticity means it's like elastic band. You can stretch it and shrink it, grow it and shrink it. That's the idea behind elasticity. Now, what are we growing here? We are growing the number of resources allocated. So, for example, I can create, and this time I want to say that, I want 100 machines, or maybe something like that. So I will say, give me Ubuntu $5 machines in the San Francisco area. And by the way, I want more. See that? I can get 10. And so 10 machines will be created as soon as I click the create button. And of course, every time you create a machine, there is a $5 charge. By the way, this is a per month charge, not a instantaneous charge. So if I have this machine running that I have started already, by the way, this one, it has an IP address. So you can see that IP address, I can copy it. And now that I have that thing running, what I would like to do is I would like to connect to it. So I'll say SSH root at IP address. And here we go. We should be able to connect to that machine just like that. So I am connected to my Bangalore machine right now. Here we go. This machine is in Bangalore. And I just connected to it from here. You can also do the same thing. It's very simple. Now this sounds like magic, but it is not. I'll walk you through exactly what just happened. You probably know this, some of it, some of you don't, some of you do. But let's move. The idea is you can connect to that machine in Bangalore or wherever you created it, and you can destroy it pretty much like this. And I can say, I want to get rid of that machine. I don't want to pay any more. I'm done with my usage. So I'll say destroy and say bye-bye.
And Nilesh?
Yes.
Can you add like CPUs or memory after you've created one, or do you need to drop and recreate?
It's easier to drop and recreate because the hassle of adding some CPU and RAM is the old way of thinking. It is just treat them like, I'll describe a good analogy, right? So, imagine this scenario. This analogy, by the way, does not work with India. So just pardon my people from India. Sorry about that, but I'm going to use this. It doesn't work in India for Hinduism reasons. So just ignore the Hinduism part. The idea is, if you have cattle and a pet, right? Imagine you have a pet and the pet gets sick. And what does it take care of a sick puppy? What does it take to take care of a sick puppy? You have the mom, the dad, the child, everybody in the family is basically worried about making sure that the puppy gets well, right? That's what people will focus on. They'll take care of the pet. And so the idea that you just described is about adding more CPU, adding more something, is like taking care of the pet. You have a machine in your data center and you want to baby it. Now that is the old way of thinking. Now imagine a different way. And let's keep these pets aside, keep them in your home and all that, fine, nice and fancy. So great. But in the cloud, things are more like this. You have a cattle, and imagine you have a cowboy with 10,000 cows in Texas. The cowboy is mounted on top of a horse. He has a gun in one hand and a whiskey in the other hand, and he's like shepherding these cows. He wants them to go somewhere. And one cow falls sick. What do you think the cowboy will do? What do you think?
Well, I think you're trying to say he would just shoot him.
Exactly. And that is exactly what should be done, is shoot the cow, move on. And, you can always create one more cow. It's easy. I mean, not practically about cows, but in server land, in cloud land, it is totally easy. Just create a droplet.
Yeah, okay.
And when you're done with it, delete it, kill it. And by the way, the bill now, the bill for this, it's $5 per month. And I just used like a minute. So the minute of usage is like something like, divide this number by 30 days and then 24 hours and then 60 minutes. So it's a per minute charge. The pricing will be something like, let's see the pricing of this. Okay, Digital Ocean pricing. The pricing is ridiculously cheap. So let's go compare the pricing. The pricing for a machine is, on an hourly basis, 007. On a monthly basis, 5. You get a big size, decent size machine, by the way. And you can get more. You can get bigger sizes machines, as big as you want. And so you can get more of these. And that's totally awesome. I mean, but yeah, I'm just describing a point. The point is, even the biggest of machines is like $1 an hour. Not that expensive. You can actually accomplish quite a bit of work in that hour. If you have this machine, 64 gig memory, 20 core processor, it's a gigantic machine. By the way, this is just one machine. The idea behind what I'm going to describe in terms of shrinking and the concept of elasticity is a distinctly different idea that I want to talk about. In this picture you're looking at here, this method of using this machine versus growing into a bigger machine versus even bigger versus even bigger, this method is called scaling up or down. You make the machine bigger and smaller. That's the idea of scaling up and down. This is also elasticity, by the way. You can make it bigger, make it smaller. This is one way of thinking about how big or small can a resource be. This idea is called scaling up and scaling down. When you have a 2 GB RAM, grow it up to a 4 GB RAM, that will be considered up scaling or down scaling, like that. Similarly, we have another way of thinking about scaling. That is also elasticity. And that kind of scaling is called out scaling and in scaling. Now this is described better in a different picture. So I will go to that picture and illustrate that point. The point being, let me erase a couple of these things. So the point is, if you have, let's say, this machine out here, right? This machine sitting here, the one that moves, and you want more. So what you will do is create more like this. And this, what I'm doing is, scaling out. And I don't want any more of these machines, I'll add that many more. I'll just scale back in like this. And I want to grow again like this. And this is scale out. Now this is scaling in, scaling out. This concept you can accomplish through automation, and this idea is the core idea behind this definition here. It says rapid elasticity. You are basically growing and shrinking your machines as you need, or as you don't need something, you can shrink it back. For example, this idea of, day after Thanksgiving. That Thanksgiving, people start shopping, and so you need more machines out here, right? So Amazon.com or people like that will actually get more machines installed and run their stores comfortably so that people can then crazy shop all the way through Christmas. And then returns period comes over, and end of the January, mid-January, they want to now shrink back again so they can save money. And that's what they do. And this idea is elasticity concept that is described here, rapid elasticity. You can do it programmatically or using mouse clicks or whatever you feel like. That's the fundamental concept. Now, having said, let's move to the last one, measured service. The fifth characteristic is that anytime you create a machine like this, like I just did, and then I killed it, I will get a bill. That's what it means by measuring. So you will see that I have some bill somewhere in the settings section. They will send me a 007 cent bill. Maybe they will accumulate it for the future. So they will accumulate it for a certain amount and then charge me. So yeah, I owe them 85 cents and the usage was 81 cents and something like that. So very, very low usage because I don't actually use this cloud. I'm just showing you because it's the easiest one to visualize. There are more complex looking interfaces, but this is the easiest one. That is the reason why I picked on them. There is no other reason. We actually don't have any droplets here in my account. I don't use them currently, although it's a good cloud. Okay, back to our discussion. So we discussed these 5 characteristics. On-demand self-service, anytime you feel like you get it. Broad network access, meaning you can access these machines wherever you are, as long as you have internet connection. These machines are shared with other people, other companies, other competitors, other organizations, including people in North Korea, for example. You don't know, if Kim Jong-un or whatever his name is going to be renting a machine right next to you. That may happen. Who knows? I'm just scaring you. But yeah, that's the point. It's resource pooling. We can prevent those concerns and make sure that they are taken care of in a systematic fashion, but just understand that it is shared. Rapid elasticity, meaning it grows and shrinks. Shrink as in grow, scale out and scale in. Those 2 aspects are described here, right? Scaling out, scaling in, as well as scaling up and down. Both are scaling, but one is horizontal. The other one is vertical scaling. That has to be clearly understood, that we are scaling like this. That doesn't increase the number of machines. We are scaling like this. It does. Both are scaling, and they indicate elastic nature of the cloud. It can grow and shrink. The underlying concept here is it gives you an illusion of infinity. Like infinity. Illusion. It's not real, but it appears like, okay, I can keep scaling like this. Like all day long, I can keep growing like this. And there's no limit apparently. Is that true? There is some limit somewhere, but it appears as if it is infinitely scalable. In reality, it is not. But to a customer, this is what they will see. At least Amazon will, or big clouds like Amazon, Google, Microsoft, they will make sure that they go great lengths to take care of the concern that people have is, hey, is it really, really big enough for my need? And yes, it will work out. So 5 characteristics you have understood, I hope. If there are any questions at any time, just open your mic and talk. Any questions are welcome anytime.
Nilesh, I have a question.
Yes, please.
In what scenario would you scale up as opposed to scale out?
Okay, I'll describe that very easily here. So the idea is, you're asking about out versus in. and up versus down, right? When do you do what? So there are certain things to look for as to when do you want to go this type of scaling versus when do you want to go this type of scaling. One of them, or the easiest way to think about it is, what is the constraint? Constraint. Like, what is the limiting factor? Like, what is the bottleneck? That is what you look for. If your bottleneck or the problem area or the trouble spot is CPU, for example, let me give you exact example of this here. So right now, if you look at my activity, you see that my CPU consumption is 69% consumed by the Zoom application, which is expected. You have other things consuming not much, right? OneNote is consuming some 4% and some other activities going on. I'm looking at my CPU metrics. So I'm measuring as to how much CPU is consumed. But I have a ton of processor horsepower here. We have, 8 processors in this machine. So it's no issues. We can handle it. It is not a bottleneck. This machine is not bottlenecked by the CPU consumption. If you look at memory, I have a capacity of 32 gigs of physical memory available, and I'm actually using 16, so no big deal. And I have a bunch of things running here, virtual machine running, and Zoom software running. So it doesn't really bog down, doesn't get bogged down. Now, back to your question, how do you identify a constraint? So you have to address that constraint, the bottleneck, and then find out which one will be a solution. Is it this or is it that? Now, if your CPU is getting hammered and is getting close to 100%, that means you need a bigger CPU. So if you want a bigger CPU, you go this direction. If you need more memory and your memory is getting full, for example, so let's go see here and let's go to a live machine. So I'm going to go to a live computer right now and show you the thing that I'm describing here. This is the Cloud Genius website performance. You can see it live. You can see that the memory consumption at the upper segment here is in this segment. You will see that out of the 4 GB RAM on this box, I'm consuming 1.99. It's kind of half of what is available. It's a 4 GB box, and I have consumed 1 GB of RAM. Now, if I run something more, if a lot of people actually, why don't you just open the Cloud Genius website and watch what happens to this right now? Just click Cloud Genius. You will see that this activity will change. You will see that the CPU consumption will grow up. You will see that the memory consumption will slightly grow. And if that reaches a point where I feel that it is really getting a bottleneck, if my users, meaning you, if you complain, hey, your website sucks, then I have a problem to address. And I will address that problem by adding more resources, depending on what that bottleneck is. Is it memory? Probably not. I have still 2 GB left here. And then, is it CPU? No, I have 4 CPUs, and not any one of them is hitting 100%. So I have no problem there. So I don't think the problem is about CPU or memory. The real problem happens in a variety of different fashions. So in this scenario, if I add more CPU, it is not going to help me. It's already underutilized. So this direction is not the right direction to go. However, if I add more users hitting the same website, then in that case, I had to address and divide that workload in terms of people hitting, and this scenario of scaling out will be more appropriate because I can always address my customers, which is you, by adding more resources. And the idea here is that let's draw an illustration very clearly. So right now, let's say if you have one machine, for example, this one, the idea is somebody like you will approach the main endpoint, which in turn divides the work among a bunch of boxes, and this in turn connects to some database. Now, if lots of you show up and visit the website, like here, lots of people start showing up on the website, this machine is going to get bogged down because it is the workhorse. This is the workhorse, by the way. This is the database. It also might get bogged down, but this idea, the gatekeeper here, this is not a workhorse. All it does is just say, okay, you go there and you go there. So other people that might show up on the website, this traffic cop might decide, you know what, you, sir, if you visit, I would like you to go here. And you, when you visit, I would like you to go to this machine. And so they're basically dividing work here among these two guys, like this, 1, 2, 1, 2, 1, 2, like that. The work is divided. And that's how you can identify if more people getting hit, that these boxes are getting hammered by the work that is getting divided. Then at that time, you should look at this machine and say, you know what, one more is a good one. And then the work gets divided among 1, 2, 3, sorry. Okay, bring it back. So it gets divided among 1, 2, and 3. So the in and out scenario is more relevant in that case. So let me go back to where I was. Here, cancel, and here. The scenario would be that you add more scale out scenario if your people who are visiting your sites and services get hammered by the load. So you have to identify what is that constraint and address that accordingly. In some cases, this is more important. The typical cases in which scaling up is more important is where you're using the CPU heavy or using your memory heavy. Those are the two cases where you're hitting that bottleneck. You should scale up. And if you have more users, you want to scale out. That's the quick way of thinking about this scale out and scale in, or scale up and down business. I hope that answers your question. Now, essential characteristics we covered. Let's go look at the 3 service models. Like, what is a service model? Like, what's the idea? There are 3 service models defined here in this definition. Those 3 are like this. It is, it has been, I would say, exaggerated in terms of the industry today. People have used this idea of X, Y, Z as a service. They just have, exaggerated this. In fact, a couple of you in our group here are actually responsible for a variety of services in your companies, in your organizations today. And so this, what I'm talking about. But the idea is, if you provide something like infrastructure and give that as a service to people, that becomes infrastructure as a service. If you're providing a platform as a solution to people who are going to use your service, you become a platform as a service. And if you're providing software as a service to other people, you become a SaaS. Now, that's the commonly understood way of describing these service models. But let's go deeper in terms of understanding what is going on under the hood and what is a platform and what is considered software. So let's begin with the easiest one, software as a service. Can you give me some examples of what these things are? Like, software as a service.
Salesforce.
Yes, here you go. Absolutely beautiful. So this is one example, Salesforce. Here is another called Office 365. Is a software available to all of us as a service from Microsoft. I just provisioned accounts for you, Office 365 accounts for you, and it's available on demand. There's a plan and pricing, and you can get these applications for $8.25 per user in your company, or maybe even more expensive. And you can keep adding more money and get more features. And that's how people sell software today. Just 10 years ago, you used to go to Staples, and you will find the shrink wrap Office product. Let's see if you still have it, shrink wrapped Office Professional. Is it still available? I don't know if it's still available or not, but there used to be a thing called, buy Office, like this, for example. You've seen this thing like long ago, right? That's how Office used to be sold, right? You remember this thing was like $500. I don't know who bought those, but there were people who used to buy these things for the price here is, I think, 120 something mentioned in the picture, but it's an eBay listing, whatever. The idea is this model of delivery of software has switched away from this model to go buy shelf shrink wrap products to something like, another example would be Adobe Creative Cloud. Now, these guys have created another software as a service available to all of us for $20, $25 per month. You can choose a plan, get the entire collection, $50 per month. That's the plan. The idea is you don't have to spend $3,500 for a shrink-wrapped software. All you can do is just pay them this money every month, and you can access all of their software on a rental basis. That's the idea behind software as a service. There are a ton of different examples you can keep going and describing. This is the simplest way of thinking about, but also the most complex way to build. It takes a lot of effort to build this thing, because you have to then rely on the underlying thing to run your software. So there is a software developer, right? Software dev. This developer, though, that team of developers will actually develop some software and then run it as a service. That these developers need something under the hood. And whatever they need, you can generally call it the platform. That's what I'm describing, is generally whatever that developer needs to run their software as a service is what is a platform as a service. You can generalize it like this. But let's go deeper in understanding what does that mean. This platform has to be built by somebody. We'll call them the platform developer, right? Let's call them the platform developers. They will build the platform that the software developer will then take and run their SaaS. As a service. They'll give their software away as a service so that people will be able to rent their services like this, $9, $49, whatever else, services available. And so the Adobe as a software developer will take that software, run it on some platform, and then provide that service to you. This is you using that software. And you pay $49 per month to this company, Adobe, and they're developing their software. They run it on some platform, and the platform developers will develop the platform for the developers. The customers of these guys, they are the customers. So if you draw the picture another way, the idea is you have a customer, which is you and me. We have software developers who are providing software as a service, and they get money. Similarly, if you look at the software developers, they are the customers for platform developers. And these guys developing a platform that software developers use, and they get money. If you keep going down here, you have to look at the platform developers' requirements, and these guys need some hardware, machines, infrastructure. So they look for infrastructure as a service developers. These guys will develop those DigitalOcean type solutions, right? You get to DigitalOcean here, and you click to get a machine ready. That's infrastructure available on demand. And so that's the infrastructure as a service. These guys will give them infrastructure as a service, and they will pay them money, like 0.007 per hour for 1 hour usage of that cheapest machine you can get. That's the idea behind this whole chain. And you can keep going from the end customer's perspective all the way down to software developer, down to platform developer, down to infrastructure as a service developer. And you can keep going down. Do you know who's the underlying thing here below infrastructure as a service people? There are companies that actually make those machines. So you may have seen these racks and racks. Somebody makes these things, right? Do you know who makes them? Anybody? Do you know who makes these things?
Dell.
Dell is one of them. But you know what? Dell, HP, IBM, all those big companies that actually seem to make it. They seemingly make these things, but let me tell you, they don't. The real companies that actually make it are, Compal, Quanta, and a bunch of other Taiwanese companies that actually make it. They make the stuff. These guys just put a sticker and a sticker price, and they sell to their infrastructure as a service or other companies. You can buy directly from Dell and IBM and Quanta and Compal, and a bunch of other companies makes it. Flextronics is another company. Flextronics. They also make the iPhone, by the way. These guys actually manufacture the iPhone. Flextronics makes it. So, and Apple actually designs it, but they don't actually manufacture. Maybe they have outsourced it or they have their own location. But without going into the detail of how manufacturing happens, the core idea we are describing and discussing is that these companies make these boxes. But underneath these boxes, there are certain things that go along to build it. And one of those, actually two of those, in those boxes, you will have something like a CPU, some storage, sometimes memory, of course, memory is always there. And sometimes you have networking components. So each of these components are made by companies like, here AMD or Intel. These companies will make the CPU. Storage will be made by companies like Hitachi, EMC, Seagate, God knows how many others. Memory will be made by memory manufacturers. Network devices will be made by network manufacturers. And the idea is to assemble all these things together and provide it to companies that actually assemble those racks, and then give it to infrastructure developers, who in turn will give it as a rental basis, ready to use virtual machines, to platform developers, who in turn will provide their platform to software developers, who in turn will put their software on top and provide that as a service to the end customer, which is you and me. Right? That's the chain. So now going back to the definition and the description of this model that we're talking about, infrastructure as a service. You can read this detail. I'm not going to read it for you here, but you have it. You have links to this in this site. There is a link to it, and you can read about the definition. And there are ready links for you to read and consume, in little short videos to describe that concept. So follow along whenever you have time, before the class, after the class, but don't do it during the class. It doesn't make sense. And so back to our discussion here, the idea, infrastructure as a service, is to provide infrastructure services to people who need it. The platform definition is the ability to provide a platform for somebody else to deploy their software. Now, platform as a service concept is slightly tricky to understand, so I'll elaborate more on that. Software as a service is very simple to understand. You just get that software and you rent it and you use it. It's simple to understand, but the platform aspects are kind of sort of complex to understand. So I'll elaborate a little bit on that. Now here, this is the classic example of a infrastructure as a service. You get some machine, you rent the machine, create a droplet, boom, you get it. Similarly, there are a bunch of other companies like here, Amazon.com, go log in, and you will find that I can log in there, and the login should be quick. And I will have to have another factor. What I'm doing right now, do you know what this thing is that I do that some of you probably find it new? But what am I doing?
One password.
Right. The idea that I am doing essentially is not just that specific thing called one password, but the other idea is called second factor authentication. That is the core idea I would like you to understand. And remember, if you're not familiar with it, start using it. It is a security concept that I want you to understand. If you're not using it, get on using it. Start using it. Every bank that you have an account with, force them to enable 2FA, second factor authentication. The idea is not only you use a password, but also another factor on top, that code number I typed from one password and then provided. This method is called second factor, and we'll talk more about it at an appropriate time, but I'm just pointing it out. Now, having said, in Amazon Cloud, I can go to the infrastructure services segment and launch a machine, pretty much like DigitalOcean. Click launch an instance, click to choose an operating system, and click to choose a size, how big the machine should be, and click to review and launch. And that's how you start a machine. So it's on-demand creation of infrastructure. That's the idea behind infrastructure as a service. The idea is to be able to get any kind of hardware you want, any number of such devices or equipment that you want on demand at a click of a button or using an API call. That's the core idea. Now, some description about platform as to why it is relevant and how it is, how to understand it basically. Let's go look at that. So in order for you, specifically you, to create something that becomes a software available to your customer. So I'm talking about you as a person. You're a person who is going to create some kind of a software as a service. You are going to do that, by the way, and you will, in the program, you will do it. So the idea is that you will pick some software and you want to give it to your customer as a service. And so you want to run that software, you have to understand what does it take to get your software package and load it up on something so that this customer is happy. How do you identify? So you basically understand from the software developer standpoint, what do you need? What do they need? The developers of that software. You ask that software developer, and then make sure that you identify a platform as a service that meets that need. So that platform that you are choosing has to meet that need. Now that was a very general way of describing. I will go into a very specific example to help us understand what does that mean. And we will begin with the customer. A simple example would be that a customer would like to have a website. Something like, as simple as something like this. Let's go see. Yeah, this is an example. Some website. I want to build this website available, and it's going to pop up here. Here we go. This customer wants to have a website like this. How do you build this? What does it take to go and build? So in this specific example, we have chosen a open source product called WordPress. It is open source here. And this product, I think I went to the wrong website. This product is open source, available on .org, not .com, but .org. That is the product where you can download this application called WordPress. And you can just click this button and you receive it. There are a bunch of people that actually develop this software. Those developers will be able to tell us what are the requirements. And so here is the requirements definition. And you can see that in this, the requirements to run WordPress, we recommend that your machine supports this and this and this. So 3 things. They're saying that we recommend that you need to have these 3 things: PHP, MySQL, and HTTPS support. That's really it. That's it. So you have to have these 3 things. Now that is what the platform should provide. Now let us see what these platform as a service providers provide. Here is an example of a company that is a classic platform as a service company. This is a company now owned by Salesforce.com. This company is called Heroku. They're a commercial product, but the idea is that they allow a variety of applications to just run. You take the application, you literally throw it on top of the platform. You take the app and you throw it on a pass like this, and it runs. That's as simple as that. It is unbelievable when it happens, but that's the idea: is take your application, throw it on a platform, and you don't worry about it. It runs. That's the concept. That's the simplicity that these guys have built over the years. They're one of the oldest ones, established ones. There are many such companies, like another one is Engine Yard, a very famous commercial company that is also a platform as a service company. The idea is to take any application you like, and you basically look at the application, ask the developer what do they need. They will need some kind of a language, for example, some programming language. And for that programming language, they will require some other things, such as the example we looked at was requiring PHP and MySQL and HTTPS. That's the 3 things that they called out. That was the WordPress example. And for every application, there will be some programming language in which the application developer will write the application and will call out some dependencies. Like, I need to have these things in place for my application that I have written in this programming language to run. So similarly, there is, the 10-year-old Twitter.com. This application, Twitter, that used to run, today it is not, but it used to run in a language called Ruby. And the developers of Twitter required Ruby on Rails as a dependency. And so as long as you have Ruby on Rails running, you can take the Twitter application and run it, and it will generate what looks like this. Pretty much like this. Now today, it doesn't run on Ruby on Rails, but I'm just saying that 10 years ago when it started, it used to run on Ruby on Rails. So what does that mean? What does that boil down to? Go to a platform and look at okay, what can you do for me? And so the idea here that describing is that you bring your JavaScript application, or you bring your Ruby application, or you bring your Java application, or your PHP application, or your Python application, or your Go application, or God knows what this thing is, Scala application, and another one, I don't know what the picture is, a Clojure application. So any language you choose, you take your applications in any one of these languages, and you get an idea, you write that application, and instead of worrying about all this complexity that you have, that you see in this labeled chart, you erase all of that, and all you focus on is deploy. Take the app, give it to them, they will manage it, they will scale it out, in, up, down, whatever it takes, and you get the application running on your web browser, on your phone. That's the idea. You don't have to worry about all this complexity that goes under the hood, but instead focus on your idea, your deployment, and that's it. They'll do the rest. You pay them money, but of course, the idea is simplification. And that's what platform as a service providers typically do. These are commercial companies, by the way. And so to compete with them, there are open source solutions. Like, here is one. Here is an open source application that many companies use. This is open source, by the way. And the idea behind this is Pivotal. You may have seen this name Pivotal in your company. Pivotal in your company is many of your organizations are actually using this particular application, which is basically Cloud Foundry, this open source. Now, what this Cloud Foundry does is pretty much the idea that these guys started with. You take any language you like, build your application that you have, you focus on building your application, and you give it to that Cloud Foundry, give it to Heroku, give it to Engineer, give it to any platform as a service. They will run it for you. Don't have to worry about all this thing. That's the core idea behind platform as a service. Meaning they make money by worrying about all these things, like, whether which IaaS provider to use, how do you set up the operating system, whether you use containers or not, how do you store the data, how do you orchestrate containers, how do you connect, make sure that the network operations correctly work, make sure that the site is up and running and live all the time, your reports are getting logged, everything is taken care of from a user's perspective, so that you as an application developer don't have to worry about these things. Instead, you focus on your application. That's the concept, the underlying idea behind these guys. Like an example here, another example here, you bring your language of choice and you focus on developing your software. You don't have to worry about the cloud. When you don't have to worry about the cloud, that's where platform as a service comes in. So a platform as a service developer will worry about the underlying infrastructure and all the complexity, and we'll go most of it in much deeper. And we will actually build our own platform as a service using another open source product in this segment. We just like, you saw Cloud Foundry, there is another one called here, Days. So there is an exercise available somewhere here. You will find it in this sequence. It says, deploy your own platform as a service in Docker containers. So that's an exercise. It is just a one page, but let me caution you, it is quite intense to finish it. You have to really carefully do it, understand it, but there are lots of building blocks before that. So this is, I think, one of the exercises you have is to run your own platform as a service. And then once you have your own platform ready, that you will take an application and run it, and then have that app, see it go live, up and running on your own. So you will begin from using an infrastructure solution, deploy your own platform as a service. At the end of this cloud technology segment, we have that exercise, we'll do that. And then you will throw your application on top and see it go live. That's the idea behind using a platform. But our goal will be to understand, how do you build a platform? We'll go to that level of depth to get to a point where we really, really understand these things. So that's the concept behind platform. It makes developers' life easy so that they focus on the application development and not worry about the underlying complexity that the cloud usually entails. However, our goal is not to become a developer of applications, but to understand cloud. And we will actually build all things up from the ground up. From the point of view of infrastructure level, IaaS level, we will build things up all the way to the top and actually have all these things automated in some very specific fashion using another open source tools. Like in the second or third segment, we'll see these exercises that you will be doing yourself. And we will focus on those activities as we go along. So at this moment, I would like to pause a little bit and ask for questions. And by the way, I am very bad at not forgetting to take a break. So anytime you feel like, I've been reminded that I just ignore taking any break. So if you need a break, it is totally okay to just ask me, hey, can you please take a break? And that's totally fine. I tend to forget. I'm just acknowledging that people have in the past told me that, hey, I just don't even remember to take a break. And so it's okay to ask me, hey, can we take a break? And we will do it. The best way to do that is just open your mic and speak, or chat in that group chat, the one that we have, 2017, January, whatever. So if you want a break, I think now is a good time to take a break and also think about what we just discussed, and we'll go further along. So we'll take a short, 5-minute break, 10-minute break, whatever you feel comfortable with. And not Gmail, but google.com, and look for timer. Yeah, so here is a 5-minute timer. We'll start the break right now. And I'm not going away. I'm here, so you can ask a question if you have in that period. Anything, but just don't keep it technical, because other people who are going away will miss it. So if you general questions, if you have, go ahead. I'm not going away. I'm here.
Nilesh, can you hear me?
Yes.
All right, sweet. Just want to make sure.
Hey, Tyler.
Hi there. Sorry, I was stuck in traffic, so.
No worries.
Perfect. Thank you.
If you don't have anything else to do, can you see if you can resolve my login issue?
Can you share your screen, please?
Sure.
Thank you. I'll stop sharing my screen and just look at your screen and see what's going on.
Hold on. Let me close a few things.
Yeah, so in your website, what I suggest is go to the Cloud Genius website and attempt to log in. But before you log in, I would like you to clear your cache.
So I'm clearing everything other than passwords.
Okay, what is this thing?
It's a history eraser.
Yeah, I don't want you to use this. So close it. Yeah, close it. Yeah, I would like you to go to settings, and in the settings, like there, and go scroll down to
Advanced,
and scroll further down to clear browsing data. And clear browsing data and remove everything, including media licenses, keep your passwords, and clear browsing data. That's the right way to do it. Now, while you are at it, go to the extensions button and disable certain extensions that you have. I don't want you to use that exotic software. So remove your scroll down. I would like you to remove this history eraser and mod header, and Grammarly also. And by the way, disable everything. We don't need any extensions. You just disable all of them. We don't need them. You can bring them back when you want to, but just stop using extensions. We don't need them. And close your extensions window, close your other windows, go back to Cloud Genius and click the membership button. And that's how you should use. You should also, the less is more. Remember, less is more. You will hear me say that quite a bit. The less things you have in your computer, the better off your computer will work.
Okay, you want me to use this or Google?
Yeah, you log in with Google. That's probably faster. So here you should log in with your Gmail. And let's go check the timer. We still have a minute or two. Try a different browser, please. Or I will just address this another way. Address the issue in a different fashion. Just to address that, we'll temporarily, disable the settings that I have that forces it to happen. So I will do that.
Okay.
So this is a feature that should be temporarily disabled. So I'll deactivate that, and that should just avoid it.
Hello, Mr. Khaled. Did you have a tax question?
I'm in that personal training game now. Can I deduct some of the training equipment?
Yes, if it's exclusive.
Okay, I think you should now log in with Google, and that should do it. I think it did that. So you should be fine by now.
Okay, perfect. Thank you.
I will start sharing my screen. So please stop sharing your screen, and I will start sharing mine in 3, 2, 1. And here we go. So sharing my screen now, you should be able to see the timer is going away. And now we ran out of time. So, okay, the break is over. I hope people are back.
Okay, I'll be back in 1 minute.
Okay. Yeah. Okay, so you are looking at okay. Yeah, I think people are maybe 5 minutes is too short a break for people, I guess. People are still not back. Yeah. Maybe next time we'll make it a 10-minute break instead. So how are you guys doing? How am I doing? Let me ask you this, question. How did we do today? Like in the 2 hours we have had. Is it good, bad, not good?
Excellent.
Good.
Concepts, clarity, my Indian accent. Any of those?
I'm just amazed at how fast you can talk for how long without taking a breath.
Wow. By the way, who was that person who spoke? Just curious.
Oh, that was Dave.
Okay. Hi, Dave.
Hi.
Yeah.
So you actually heard me. I didn't have my headset on. So
Yes. Yeah, I have a professional audio setup in my room, so I can detect any kind of noise, and I actually don't use a headset, but I hope I'm not causing any audio problems. The audio should be clean, and
yeah, you're very clear.
good to know. Good to know.
Wait a minute, did I hear right? Did you say you've already been talking for 2 hours? Just the hour.
Was it 2 or 1?
One.
One.
Oh, okay. Well, I just want to make sure because I know that it was supposed to be at 4, but I've when I was signing
somewhere I saw 6 o'clock. Where was that? I was lost. Somewhere I saw 6 o'clock, but it is actually 5 o'clock. Where was that clock that I saw? Maybe it's a different time zone I saw somewhere else. But yeah, it's only 1 hour. 1 hour.
No, that's perfect. Because like when I was signing up for it on Bellevue College, they actually had the class listed at an hour before time. Started at 3.
I know. So I know. I think you pointed out to me they haven't actually fixed it, honestly. But I should point out a couple of things now that we are talking about timings and hours. So here is the Bellevue College, and so what I'm suggesting is that this cloud computing curriculum, we run it from this office. And so, yes, the timing showing in this website is wrong. I'm asking them to fix it. Please ignore the timing there. Now, second topic. The correct timings are in this website. That website is the Cloud Genius website that is opening up. In that website, I have discussed with many of you, not all of you, but many of you, and actually have incorporated a slight change in timing to make it less ungodly. At 6 o'clock in the morning on a Saturday, was considered ungodly by many of you. So I have changed that timing, and I think the person impacted by this is Shiva. So Shiva Shankar, I would like, hey Shiva, you're listening now. So what I'm suggesting is that I have made a little change in the timing here. Please note. This is going to be 2-hour delay on Saturdays to make it palatable to people on the Pacific coast. Right, I think Shiv says thumbs up. That's good. So the idea is that 6 o'clock in the morning was too painful, and I acknowledge that. And therefore, I have adjusted it to start at 8 o'clock in the morning, Saturday. Accordingly, all the times have been revised. So you see that on the website. These are the correct timings. And below here, these are the correct dates. So if you find a discrepancy and in timing and dates, please tell me. I can fix it immediately. I have no control actually over Bellevue College. All I can do is write them an email or call them and harass them, but that's it. That's all I can do. So if there is a mistake on Bellevue College website, I'm sorry. Please bear with it. Leave them alone. That's the best way to think about. It's a government institution. It is supposed to be slow by definition. So ignore them. Ignore them. The idea is that for people who are from Boeing Company, that you have registered from Bellevue College, and so that is the thing that I want to point out is that you will receive your certificates because you registered there. You will receive certificates from that institution. You should use those certificates that you will receive from Bellevue College against your LTP, so that LTP will not charge you individually. Instead, LTP will pay Bellevue College and will not deduct from your salary. That's never happened, but I'm just saying, calling it out. The certificate from Cloud Genius is not acceptable to LTP. So you should receive the certificates you will receive from Bellevue College, and that will happen because you are participating in this program. We are running it for them. So that's the idea behind LTP and Bellevue College. And yes, the timings are wrong, and I'm sorry about it. I cannot fix it, honestly. So stay focused on these timings on my website, the Cloud Genius website. I hope that is clear. Okay, let's move on. The dates and the times we spoke, and I hope there is no issue as far as the Saturday 6 o'clock. I hope nobody is disappointed with that change. Hope not. If there is disappointment, I'm sorry. But I hope not. So having said, let's continue. Okay, so we have briefly discussed a couple of things. Let me close out a bunch of these tabs open here for a moment. So I'm showing closing bunch of tabs and get to the definition again. So here, we briefly discussed platform as a service, understood the concept, very, it's a brief sketch right now. We will go deeper as we go along, but I know we have the people in Boeing Company who are managing platforms, infrastructure services for your company are in the program here. So it's a great honor to have you guys here. And so I know your teams have been participating in our bootcamp for many years. Boeing has been sending employees, Microsoft has been sending, Expedia sends people. And the reason why I think people keep attending the program is because they find it hands-on. And that is what we will do. We'll focus it, keep it hands-on, and I would like you to practice and participate along. And those things to do are in this website. They are written down, and I'll do it with you. I'll do it with you right here in a live session. I'll create a video recording, give it to you, and I would like you to do it on your own, before the session, after the session, race forward. And I said that, and I am here all the time, almost, unless I'm sleeping, on that Slack chat, which I hope you are able to notice that there is a group dedicated that I have constructed. So this is what I am talking about. This, you see that, right? If you don't see it, I would like you to bring it in foreground and show it to you. So I'm talking about this. Yeah, that's one. That's the one. So here, not the team directory, but this group called 2017 January Cloud Bootcamp is a private group that all of us are there. We got, yeah, exactly. So this is where please chat, please crack jokes, please crack comments, questions, your issues that you run into, any problem, type it here so we can all learn from it. And so, yes, this is the right location. And for our group, this is the right location. There are other people in other groups, but they are different. This is the one that we are participating with. So stay focused on here. If you want to talk individually, one-on-one, please use the one-on-one, click on my name and chat with me. That's how it will work. And use Slack chat as opposed to other channels of communication. Like, for example, you have my phone number, you can text me, but please use Slack instead, because I can then consolidate and answer everybody efficiently. That's the idea behind this Slack application, but no other idea. You can always, text me, call me, all of that, but Slack is better. That's what I'm saying. Okay, let's take it back to the other window. Okay, there we have. So adjusting my layout and adjusting this screen here a little bit. Okay. Yep. Now let us begin. So we were discussing this definition. We discussed infrastructure, platform, and software services. I would like to see if there are any questions immediately to address the service models that we discussed. These three service models, right? We discussed this item, the three service models right now. That's what we discussed. So if you have a question specifically on that aspect, please tell me. If not.
Hey, Nilesh.
Yes.
Today I just, my company, we were just talking about Surface as a service. So what would that kind of fall under? Like, would it encompass all the three models, or?
What was that as a service?
Surface as a service. So basically they're replacing laptops with Surface.
I mean, this thing, Microsoft.
Yes.
Thing? Okay.
Yes.
So what happens is they have, honestly, people over the years have bastardized the word X, Y, Z as a service. This X, Y, this is a bastardization of the word as a service. Anything as a service, right? So now they have come up with this idea of Surface as a service. Now let us describe this. Let me give you my interpretation of what people mean by such a thing, right? They know it is not a service, it's a freaking product. I mean, come on, who are you kidding? It's a product, surface.com. So you go look at it, you can buy it. It's not a service, it's a product available from Microsoft for whatever amount of money you pay. This is what Surface is, right? It is not a service. Now, how do you create a service? That's the question. So what may be on the minds of people who are making this word up is what I will describe. The idea is we will apply all these aspects we just discussed, like here, for example, like on demand. We'll try to fit this definition to the concept Surface as a service to the extent it makes sense. Some of these will not make sense. Some of this will. So if you want to apply this definition of something as a service to Surface as a service, how will you do that? On-demand self-service, right? So your company by the way, he's from Baltimore. He's on the East Coast, Shiva Shankar Ganeshan. Can you spell the name of your company again?
Exelon.
Okay, Exelon is a
Energy company.
Energy company. So that's where he's from. And the idea behind Exelon using Surface as a device is what they're really doing is standardizing the variability in the operations of providing laptops, desktops to the employees. Is that the idea?
Correct.
Okay. So when you have this idea of Surface as a service, they want to basically apply the concept that, any employee, you want a machine, you click this button, somebody will deliver a Surface to you. That's the idea. That's one of the ways of thinking about it. Click the button, you get a Surface. Your Surface stops working, throw it away. I mean, return it to the company, and they will repair it, fix it, give you a new replacement model. Your data that you store on your Surface is not really stored on the Surface, but is stored away from the Surface, somewhere in the cloud, so that the machine itself becomes disposable. The idea is to treat a device like Surface like an iPhone with iCloud service, with iCloud backup. You get a new phone, you can throw away your old phone because you have the entire thing backed up on the iCloud, for example. That idea is going to be applied here in the case of Surface as a service, is that you have employees, they have their credentials, their documents, their things, that whatever they're working on, every single thing is backed up in some cloud somewhere, some cloud storage. It is probably your Exelon company's cloud, or maybe Oracle cloud, or God knows which cloud service you pick. But Surface will be backed up, and Surface itself becomes disposable. Meaning, if it goes wrong, return it, get a new one, or maybe get a used one, get a refurbished one from the company. It's a company-issued product, and they are standardizing it because they will reduce variability in spare parts and support contract from Microsoft and all of that cost structure. If you have standardized piece of equipment, like everybody, every airline company like Alaska Airlines will use Boeing planes and Boeing planes only, no other planes. But then with the recent acquisition, they have a bunch of other planes. So it's a complexity now for Alaska, and they bought Virgin, I think. So now Virgin came with a fleet of French company. What is that company? Yeah, the one you don't like.
Airbus.
Yeah, the one you don't like. We have 6 Boeing employees in the group right now.
Airbus. Oh, okay.
But I'm just saying, so that this situation with Alaska is that they have now 2 different types of planes to worry about and repair and fix and keep parts and inventory and all that. That becomes complex. So over time, they will do something about it. But most airline companies will buy one product, one type of product to minimize the trouble, minimize the cost. And that's what the idea behind this would be, Surface as a service, that you're cutting down your serviceability cost. Now,
So, which includes patching and all the stuff also, right? You don't have to take care of that.
Correct. Microsoft will patch it for you. Microsoft will do most of the work for you primarily. However,
Including authentication and probably all the stuff, yeah.
Right. Resource pooling, this may not apply. If you have an employee A who is using a Surface, the other employee cannot use the same machine. That is difficult to do. Pooling cannot be done on individual laptops issued to employees. You cannot share a laptop among 2 employees. It's hard. It doesn't make sense. Elasticity also doesn't make sense. One employee gets 1 laptop. That's it. Why need 2? You don't. Honestly, you don't. Measured service. I mean, there is no metering. It's a free issue to every employee because they're working for the company. So the metering part, the measurement doesn't apply. Software as a service aspects will apply because your company will have specific Exelon software runs on the Surface, preloaded, pre-installed, all the applications you have, the security patches, company-specific policies, credentials, your ID card with authentication, second factor, all of that will be preloaded. So that's the idea behind this concept. Platform as a service doesn't apply. Infrastructure is the machine itself. Private cloud, I don't think that applies, and we haven't even discussed the deployment models yet, but I'll do that. So the kind of concept of Surface as a service is to simplify the business model of operations of Exelon as a company as giving machines to employees and reduce variability. Everybody gets the same exact idea. Like even I am doing to you, I have given this exact machine to everybody, and everybody is using this. So I am going to minimize my trouble in troubleshooting any problem you run into by giving you a standardized method of operation. Of course, you can run these exercises on your own on any machine you feel like, but then I will add trouble to myself. But you're using Windows and somebody's using Mac and somebody's using Unix and Linux and God knows who or what variability. I have seen it all. And that's why 4 years ago, I started using this virtual machine so that everybody standardizes on one thing. And it brings, gives you a simple glide path to learning something. You can actually do things. And then once you know it, you can then use your Mac or your Linux or your PC or whatever you have. That's the idea of standardization. So that's the idea behind Surface as a service as I read from what you just told me. I don't know, but you can correct me if I'm wrong. Okay, let's now discuss deployment models. And this is subtle, very, very subtle thing here I would like to call out. And there are subtle things that you need to pay attention to is what will be considered a cloud versus what will be a data center in a company. There are certain things that are very distinct. And I will now describe the idea of a private cloud. Excuse me. A private cloud is strictly private to a group of people in a company, in your home. I have a home private cloud in my home, in my garage. So that is my private cloud. In larger organizations, you will have a dedicated private cloud inside your company. How is that different from a data center in your company? Anybody? A private cloud in Microsoft. How is that different from a data center in Microsoft in Renton. By the way, we have a place in Microsoft where the Microsoft data centers are in Renton location near the airport, Tuckville.
It still comes back to how you get your resources. If you want to, self-subscribe or
Yes.
create a database.
Bingo. These characteristics have to be met. These essential characteristics, if they don't meet those characteristics, it is not a cloud, no matter what you say. You have to be on-demand self-service, meaning an employee in the Microsoft company should be able to get some resource on demand. When they go to an internal website, click some button, they get allocated resources available to them. That happens because that's on demand. Now, all the company employees already have broad network access, so it is possible. But the moment you say that you have to open a ticket and somebody will create a machine, it is broken. It is not a cloud. It's a data center. That's the way you think about it. Elasticity. In a physical data center, the concept of elasticity might appear to be available, but the illusion of infinity is not. The illusion of infinity, of being able to infinitely scale out as and when you need, as and when your employees need. So let's say you have a limited size data center and you have, like, say, 100 machines. That's the limit. Now, if you have a cloud deployment, that limit virtually goes away. Not actually doesn't go away, but virtually it appears as if it is infinitely scalable. That concept has to be understood between a difference between private cloud and a private data center. These characteristics have to be met. Now, what about measured service? The idea here is that it is what is called funny money in companies. Like, you take money from one pocket, put it in the other. You've seen it. It's called activity-based costing. You've seen in your companies, you take a service from another organization in your company and you pay them funny money. I don't know what the word is to use for funny money, but you understand it. What I'm talking about is activity-based costing. Let's say your IT department says, you want to get a machine from us? So the marketing department says, yes, we want it, and I'll pay you $100 a month. That's the internal transfer of money, one pocket to the other for the same company. So Microsoft marketing will receive a bunch of resources and pay Microsoft IT some money corresponding to that. All the money stays in the company, but it's changing hands, or changing pockets, I should say. So that metering is also important, and it will apply. If it doesn't apply, it's not a cloud. That's the way you think about these essential characteristics, because that's the definition that we have agreed in the US. We have agreed to follow this definition. By the way, I must say that this definition itself is kind of outdated. Slowly, it is getting outdated. Eventually, it will get updated. But the definition, as you see here, is generally accepted. Generally speaking, it is going to be evolved eventually. Okay, let's go forward with our deployment models. You got the idea of private cloud. It is strictly limited to a group of people. One person, more than one person, but a well-defined community, a well-defined group of people will use it. That's the idea. In fact, if you go read about it, exclusive use by a single organization. That's the idea behind private cloud. There may be multiple business units, marketing people, sales people, this people, that people in the company. They all using the same shared private cloud inside the company with the illusion of infinity and scalability. They pay for it internally, private cloud. An example of a private cloud implementation will be OpenStack. One example. There are many other examples. This is an open source implementation. I think Boeing has been deploying this for quite a while now. This software is open source. It gives you a comprehensive infrastructure as a service solution. You have it. You're doing it, I know. In your company, you're doing it. If you do not know, you can ask your team members in the Boeing company. You can get access, by the way. Just for Boeing employees, I must call out. You can get access to your own private cloud for testing it out. You should do that. If you don't know anybody, talk to Sami Turan. He's here. He'll give you probably. He's in your group. Ask him. He'll give you access to OpenStack. I'm pretty sure he will not say no. And I encourage that you please play with it. Play with OpenStack, understand what it is, and bug him, bug Sami about, how do we get access to this and all that good stuff. He has a bunch of services running in your company. So ask him. He's right here with you. Bug him, please.
Hi, this is Sami. Let me clarify. So I have the relational database service and the platform service where we have Aprenda. And Aprenda is the platform for our .NET developers. And I also have private Pivotal Cloud Foundry, where we are just working on that project right now to stand up as a service for Java and other application developers. But OpenStack is another initiative that it's a project right now, and it's within the Enterprise Cloud Service group. They're working on standing up an OpenStack. But I don't have the OpenStack service.
Okay, sorry. Other people have, but he'll introduce you if you're interested. So get Cloud Foundry,
Yes.
get Aprenda, get OpenStack. Your company is playing with these tools. I would like you to go and play with it yourself. Get first-hand experience. I have never seen it from outside, but I know you have it. And I want you to get exposure. I want you to get real use with these things, because your company will not say no to you, honestly. I'm just pointing it out that these services are available to you. Make use of them. And now is a good opportunity to ask. I mean, in your company, not me, in your company. Ask Sami for pointers as to where to go and ask, and bug them. They will not say no. I promise they'll not say no, because they know that you're taking the program. They know you want to learn. They know you will help them in finding issues and bugs and things like that. And so it is good for you, good for the company. Do it. Okay, move on. Back here. So community cloud is slightly different from private cloud. The idea is that it is, let's read the definition here. Exclusive use by a specific community of consumers from organizations that have shared concerns. Now here, the mission, shared concerns, meaning types of people. It's a classification of a community of different types of people getting together. They share the common concerns, and they are sharing this cloud resource. It is kind of sort of like private cloud, except not limited to one organizational entity. So a bunch of companies together, collaborating, sharing a community cloud can be an example. Next one is public cloud. A public cloud meaning you can get it, I can get it, companies can get it, Microsoft can get it, Boeing can get it. Anybody can make use of those public cloud services. An example was here, Amazon EC2, infrastructure as a service. Launch an instance, you will get a machine. You will receive that because that's the service available to anybody who has a credit card. Right? I'm just saying that anybody on the planet who has a credit card can use this cloud. That's the idea behind public cloud. Anybody can use it. And all of us, by the way, you should have created an account with a variety of cloud services by clicking on this button here. That gives you access to coupons. And so most of it is free. Like here is a free for 1 year usage of Amazon. Here's a free for $300 for Google. Another free for Giant, another free for DigitalOcean, another free for Azure Cloud. So a bunch of different free options are available here on this page. And you can sign up for all of these, and it doesn't cost you a thing. So make use of these services available. We will actually expect you that you have an account already with these guys. But remember one thing, only one thing to remember. With these public cloud companies, one thing to remember. You have to give them your credit card. What does that mean? If you are using your service and you are exceeding their terms and conditions, they will charge your credit card. That's one thing. Second, you look at the pricing and see how much they will charge you and understand that pricing. If you don't understand it, call me, let's figure it out. And the third and the most important thing, if you start using a resource and you forget to kill it, you will keep accumulating a bill. And I know in our program, many people have forgotten to shut down the machines and kill and terminate them, and they'll get hit with a bill. I don't want that to happen to you. So please remember, when you're done with a thing that you're playing with it, or learning or exercise, whatever you're doing, after you're done, remember to terminate, remember to destroy, remember to kill. Different people will use different words for it, but kill, terminate, destroy, that stops the bill. Stop doesn't stop the bill. That's a crazy thing. In Amazon, you will find stop a machine doesn't actually stop the bill because the machine is still allocated to you. So remember these things. You have to kill, destroy, terminate to stop the bill. That's the most important thing. You using your credit card, remember to terminate after you're done learning, doing whatever you're doing. If you want something for business use, keep it active. But if you're done playing with it, stop it, kill it, terminate. So stop the bill. Remember that. Okay, moving forward. Here, in hybrid cloud, that concept can be a mixture. In here, they describe two or more distinct cloud infrastructures that remain unique entities but are bound together by standardized proprietary technology. The idea is something like this. You have one company that uses a private cloud in their company, and they have a bunch of equipment installed. This is their private cloud. Now, what they want to be able to do is what is considered as bursting into the public cloud. And this may be useful to provide that illusion of infinity. When you have a limited capacity in your private cloud and you need more, you can burst into the public cloud and thereby give this illusion of infinity to your users. And when you don't need all that extra capacity, you can basically shrink it and get rid of the public part. So a combination of a private and public can be considered hybrid. When you have such a combination, you make a hybrid cloud. That's one way of thinking about it, thinking about hybrid cloud. Another way of thinking about hybrid cloud is something like this. You have some deployment in the Amazon cloud, some in the Oracle cloud, some in the Microsoft cloud, and a bunch of other companies. You can mix and match. Nothing prevents you from mixing and matching. This can also be called hybrid cloud. By the way, this contradicts what the definition says, but generally people have been using this word. This, by the way, contradicts. The definition doesn't allow that. It says it has to be two or more distinct cloud infrastructures that either public, private, or community. So you mix and match private or community or public. That's what makes hybrid. But I'm giving you a different way of thinking about it. This can also be hybrid, although definition doesn't allow that. The definition says public-private mixture is hybrid. Community-public mixture is hybrid. That's what definition says. But this is also generally accepted, not included in the definition. So that's the 4 deployment models that are defined here. We can come up with more concepts. You will run into these things that are not included in the definition occasionally, and we'll discuss those if you find something. And that basically broadly covers the core aspects of the definition of what cloud computing is as defined by National Institutes of NIST Standards and Technology, NIST. That's their definition. You have a link for this. You should read. There are a lot more things to read here. There is further elaborate appendix to this, so it's good bedtime reading. Okay, these links are available on that website here. You should be able to find them somewhere here. Now, after describing the concept of formal definition, let us understand why do businesses use cloud computing. And there is a little thing here, which is, you should be able to read that. The underlying idea essentially is, excuse me, I'm not playing these videos right now here because that doesn't make sense, but I'm going to describe that concept here. The core concept that I think I want you to remember is the word core competence. This word, many people use today. Many companies will throw this word left and right. This word was defined and coined by my professor. His name is Prahalad. This guy, C.K. Prahalad, was a professor at University of Michigan. He died, I think, 5 years ago, unfortunately. But he coined that word core competence with another professor from Harvard Business School. The idea behind this word is that you stick to your core competence. And that is what you should be focusing on. So now, let us see. What is the core competence of Boeing company? Is it the management and maintenance of data centers? Probably not. You know, the core competence of Boeing company is manufacturing airplanes. That's where they make all of their money, right? That's the primary product. And some secondary products are support services around planes and all that, commercial aviation, military, and all those things that you constitute. That's the core competence of your company. Similarly, core competence of companies like Microsoft. What is their core competence? Is it managing and maintaining data centers, managing writing software, or is it managing payroll processing for employees? It is not payroll. So what is not core competence is payroll for their employees. So what should they do with the payroll? Outsource it. Outsource it to somebody who knows and who has payroll as their core competence, such as a company called ADP. Give it to them. And you focus on running your cloud services, running your office services, running your Windows as a OS platform. So you focus on your core competence and let other people do other things, such as what they do best. Is their core competence is, for example, payroll or some other services that other companies need, right? That's the core idea about thinking. So you should use cloud when cloud management and maintenance is not your core competence. And you should actually provide cloud services if that is your core competence. So if you are a payroll company, like ADP, for example, you should not outsource your payroll because you know how to do it. So you do it. But if you're Microsoft, you should run your own cloud service. If you're Boeing, you should probably not, because that's not what you do. You make planes, right? That's how you should think. If you are a energy company, for example, energy company like your company, ships company, it's energy. So the idea is the energy companies should not be primarily focused on building and managing their data centers because it is not your core competence. Your energy company's core competence is to make sure a couple of things. That people reliably and safely receive energy at a variety of endpoints, gas, electric, whatever you have. And another one is to collect the bill on time every single time without fail. So you make the business run successfully. That's the core competence of an energy company. And you will go into the depth and detail needed to measure your utility consumption, heat, all the thermodynamics associated with your gas pipelines, all of that thing that matters to energy. You focus on that and not worry about managing your data centers in your computer centers, because that should be outsourced. That's the idea behind, focusing on core competence.
Nilesh, I have a question.
Yes.
Wouldn't this conflict if the energy company is trying to build a private cloud versus a shared cloud or something else?
So
they have there's social security numbers of all their consumers and everything else. They would like to keep them in-house and safe.
Yes. So you're talking about this thing called security, right?
Correct.
That we'll cover this in great depth, but don't worry about it. Right now, our focus is to think about what is our core competence and make sure that we are meeting those requirements and staying focused on our core first. Everything else you should be able to outsource. You can outsource it in a variety of fashion by say that, this is my building in the energy company and I maintain and manufacture my gas and electric and whatever else that I have. And I am able to do that. But in my own building, I can have a third party come in, like a TCS, for example, in my building and have them run my private cloud here. And they are in my building. So in my firewall, within my boundary, I don't lose my security. I can have my private cloud, but they are managing it. I'm not. I don't have to. That is not my core competence. I outsource it and put a condition. You come to my building and do it here. That is possible. People do that all the time. That's one way to implement and address this concern of security. I need to have my customer data in my building. Fine, do it here. Ask somebody else to come and do it for you because they know how to do it. And so an example would be asking Pivotal company, the company which is EMC's part of EMC. EMC comes into the company Boeing and helps them set up Pivotal software, the Cloud Foundry application. They're helping them, consulting with them, and all that. They're doing it for them in their company. Boeing is a security conscious company, and so they make sure that the critical aspects of their business are in the building, and they go great depths in making sure that security is intact. And that is one of the reasons why you have a private cloud, because you don't want it to go on the public. That's the reason why you're building infrastructure on this OpenStack and all that, which is a private cloud, by the way. And even this is open source, so you can actually install it locally. You don't have to go to the public cloud if you don't want to. But it's the idea of core competence is to staying focused on what you do best. Think of it this way. When you are in the school, like, kindergarten and all the way, to like a graduate degree and all that, you tend to learn a variety of topics. You will study subject A, B, and C, and if you're weak in this particular subject, you're good with these, some subjects, but this one is weak. People will tell you that you should focus here, right, as you grow from kindergarten all the way through 12th grade. So people will tell you you have weak spots, you should focus on those. And as you grow out of the school and get into college, people will ask you to specialize. People will ask you to specialize in a particular field and not worry about these other things, right? You can just ignore them. Specialize is the direction. And what happens in real life? In real life, imagine if you are a brain surgeon, and you have a Saturday, and you're a sunny Saturday, by the way, sunny. And you have a lawn that's kind of growing up, and you need to mow the lawn. You also have a neighbor. Neighbor has a teenager son. Now, this is the task. What do you think the brain surgeon should do? Mow the lawn himself, or ask the teenager and pay him $30? What do you think?
Teenager.
Why?
It's because that's a low value task. He can probably spend his time on a high value task. For which he gets paid more.
Correct. That's a good way of thinking. Absolutely right. And that's how you should say, indeed. However, I will twist the idea now a little bit. The idea is, what if you enjoy lawn mowing? What if it is not a Saturday, but a Monday morning, and you have operations to do? How will your thinking change? And that's the idea of thinking about core competence, is that if you enjoy lawn mowing and it's a sunny Saturday, you would do it yourself because you enjoy it. If it is Monday and you have to go to the hospital and do the operation, you probably not even worry about the lawn. You just go and do it. Right? That's how you should think about core competence. Is, you do whatever you do best, and everything else, you leave it for others to worry about, or pay them money so that they take care of it, or just don't even do it. Like, that's the idea. So stay focused on one thing that you do really, really, really well. And that is what is the secret of success, is focus. And by focus, you do one thing. And it also means that you do not do anything else. That's focus. That's the success idea, right? The whole idea behind success is you do one thing and you exclude everything else. Like, for example, I run this Cloud Genius company, and by the way, I don't do anything else. This is one thing. I outsource even my cloud services. I'm not into managing cloud data centers, although I can, but I don't do it because that's not what I like. So I outsource it. I use these cloud companies that you will see what I use. So you will see many examples as we go along, is to stay focused on what you do best. that is the core idea of using cloud computing, is because you don't really are in the business of managing data centers, are you? If you are, you should start a cloud company and offer services to other people, because you know how to do it the best. And that's what you should do. And that is the idea underlying using cloud computing versus creating cloud services yourself. So that's the subtle distinction in terms of understanding the idea, which I have described here in the introduction section. There are certain other benefits of using cloud. Like, why do companies use cloud computing, for example? The fundamental way of thinking about using cloud computing is economic. So imagine if you have a data center and you want to build it up. It will cost you money. It will cost you a lot of money up front to build something up. And then you will have eventually some customers, and they will use that that service that you offer them, and your company will eventually start making some profit, you hope. But even in this time period, the profit you earned and the cost you spent in building is not compensated. You still don't make any profit. Profit is, I should change the color, or maybe this is the income, let's say, and this is the cost. So instead of income, I should say revenue. So this is the revenue stream, and this is the cost spent up front in building your data center. So if you have spent so much money, say $10 million in building a data center already, you're growing revenue slowly. But are you profitable? Revenue minus cost, you're probably not profitable. You don't know exactly when you will become profitable. At what point in time in the future will you turn profitable? You have no idea. You cannot predict, because you spend this thing up front. That's a bad thing to do today. Honestly, upfront expenditure is a bad thing, generally speaking, because your cost structure is unpredictable. Instead, what if you spend a little amount of money as you grow, and this is the cost structure, because you can afford to do that and grow your machines, scale your infrastructure at the rate of 0.007 cents per hour, and your cost will eventually grow slowly. And accordingly, you will build your applications, build your services, and grow your revenue. I hope the revenue line is above the cost line. I only hope. But if that's the case, you almost immediately know that you're profitable. Otherwise, if you're spending money up front like this, $10 million, you have no idea when will you turn a profit. That is one of the most important reasons why companies use cloud computing. It makes it easy for you to predict your cost and adjust it according to what you foresee your revenue to be. If you foresee that your revenue is going to be shrinking, you can actually reduce your cost structure accordingly and scale it down, or rather scale it in, scale it out here. And so scaling, and you know that your revenue is going to shrink, and the cost you should also be able to shrink accordingly, so that you keep making a little bit of profit all along the way in a predictable fashion. That is the fundamental reason why people use cloud computing, is because you pay as you go, not upfront. The moment you spend upfront, it's like a ancient way of doing business. Don't do that. Don't do that. That's the reason why people use cloud. It is very predictable upfront from get-go what is going to be your cost. You can very carefully manage it. You can make your machines go scale out. If your revenue is going to grow up, you need to service your customers, bump it up, scale it out. You make money. because you are going to grow and the revenue numbers are going to be higher. So you can afford to scale out, no problem. You still make some profit. And as you know that the downturn is coming, that customers are not going to likely to buy, your infrastructure costs can come down because you can scale back in. If you build a data center upfront, can you scale a data center down? I don't think so. You have to sell it on eBay, which will be a loss. And that's unfortunate. But that's the reason why people use. So, there are many companies today that don't build and invest in data centers because of this exact reason. It is making it easy to predict when and how exactly can you become profitable. Okay. Any questions on this topic?
Yes, Nilesh.
Yes.
I think certain companies, like for example, in Exelon, the opcos or the utilities, I think they get some tax benefits or like the depreciation on the assets from the government, I think.
Mm-hmm.
So they were saying that they're going to do it on a slow. I mean, the cloud movement is going to happen in a slow fashion out there for the utilities because I think they're getting more. The urgency is a little less.
You're right. And so what happens is the pictures I drew here, right? The upfront investment, $10 million and pay as you go scenario of
Right.
Cloud, that applies to things that you can do in the future. But what you are describing is a case of what if you already have a data center, man? It's there already. Now what do we do?
True.
Now the picture slightly changes. This picture changes because you have spent $10 million on some equipment, infrastructure, and data center, and now you can amortize the cost that you have spent over time. So you can benefit from the expenditure you have made already, and there are some tax consequences of making use of this asset that you have put in place. So you should use that to the benefit of yours because you have already spent that money. Because when you did, there was no cloud at that time probably. Or maybe it was there and you were not risk-taking enough to actually take on the cloud. So it varies on the business of a given company. If they have spent already, yes, it makes sense to keep using it. Unless you find a buyer on eBay that you can sell the whole thing for $9 million, maybe take a $1 million loss and move on. That's great. But that doesn't happen rarely because equipment, especially electronic equipment, the depreciation is rapid. It goes like this. Exponential decay. And that's the problem with electronic equipment. Servers, you buy it today, try to sell it tomorrow, it's less than half the price. Nobody buys used machines.
Yeah, and it seems the average lifespan of a server is like around 22 months.
Yeah, 24 months, 3-year max, not more than that. And so that's what you see in terms of existing equipment. Make sure to amortize, absolutely. New businesses, pay as you go. New business data center doesn't make sense to me. Maybe there are cases in which it might make sense, right? So that's the concept behind using a cloud. Now let us go deeper in technology. Now, as to what exactly does it take to build a cloud, right? That's what we'll do.
One last question, Nilesh.
Yes,
sorry.
Yeah, go ahead.
So the cost benefit when you go into a private cloud, is it definitely lesser than what if you adapt or you go into a public cloud?
So a private cloud will involve you creating your data center. And that will always be there. You have to spend money. And large companies like Boeing can afford to do that. And even your company, Exelon, can afford to do that. Smaller companies don't go that route, honestly.
True.
There are other reasons why large companies actually go into private cloud beyond security is that, especially in companies like Microsoft and Boeing, these very large companies, the idea is that you actually play multiple games. By game, I mean it's a strategy position. You play this game and play that game also, and you see which one will win. You will play the private cloud game, you will play the public cloud game also, and see which one actually turns out to be better for your company because you have no idea right now. So you practice with multiple scenarios, see which one actually wins, and then pick the one that you like. And over time, you retire the other one. Many companies do this. Many large companies do this. I have seen in Microsoft, I used to work in a team that made this product called Link, which is these days known as Skype for Business. That is my puppy, Skype for Business. You know this. Many of you use it. And so before that, it had a name called Office Communicator. Even before that, it did not have a name. And that's when I started building it. But at that time, we had, in that company called Microsoft, we had a thing called conf.exe, which is the conferencing application built into Windows. We had MSN Messenger, we have Windows Live Messenger, we had this Office Communicator, and another prototype that did not have a name. So 1, 2, 3, 4, and 5 different products kind of sort of doing the same thing in one company. Why do we have so many different variations of the same idea of communication and collaboration? Because we don't know which one will win. So we'll play with everything that we have and understand which one will actually work out. And so over time, you have seen that this went away, MSN died, Live Messenger is probably not there yet, or maybe it's there, I don't know. This prototype got killed. Office Communicator rebranded as Link, and Link rebranded as Skype for Business, and that's the one which is like a multi-billion-dollar today. That's a multi-billion-dollar business today. I think 1+ billion. So that's the idea behind. I think we just saw Kara joined. Hi, Kara. Yeah, so a break is a good idea right now. We'll take a short break, and I will start the timer and take a 10-minute break if you like. Maybe this was too short. The 5 minutes were too short, so I'll take a 10-minute break right now. There we go. So, hi, Kara. I just saw you. I think you may be muted. Let me just unmute you.
Hello, how are you?
Hi, how are you doing? We have the whole group.
So does class start at 6 p.m. Pacific time?
No, ma'am. It is 4 p.m. So sorry. I'm sorry if I confused you, but the class timings are, let me just check it up. Okay. Let me bring up the timings to be precise. And here it is. I'm so sorry that I must be the reason for confusion, I suspect.
No, just misread it. Sorry.
No worries, but we are recording it. I just want you to know that we are recording the whole session, and we will have a video available as soon as I'm done talking. At the end of the hour, we will have a video recording available that will be pushed out to your computer as soon as it is ready. So that pushing happens through Resilio Sync, and we will use that method to proceed. So we'll do that. That gives you access to the pieces that you missed, but you did not miss much. Today was just the introductory, just to begin, get us started and all that good stuff. That's what we did.
Okay.
But it's interesting to get, we will start the next topic after this break in 8 minutes and 20 seconds. Are you able to see me?
Yes, uh-huh.
Okay, good. That's good. That's great. You're also able to see my desktop there, I guess, which shows you 8 minutes and the down timer going on.
Yes.
Okay, good. And you should also be able to see all of the people in the team here.
I see two screens, Glenn and Raj.
Okay. There is a little arrow that shows you other people. If you click through the arrow, it'll give you access to all of the people in the program. We have a total of 10 people right now, along with me. So total 11.
Okay, great.
Yeah, thank you. Hey, if you don't mind, I will also take a break for a change. I'll actually walk away from the computer. The microphone is active. The camera is active. And so you can speak, but I'm actually walking away. I'll be back in 2 minutes. Thank you.
I've got a question for you, Nilesh.
Yes, sir.
Let's see if I can find which one it is. It's like native apps versus web apps. It's module 6, units 1. There's a homework. Are you going to go over what you're expecting for homework a little bit?
So the homework here is you can either paste your responses in that Slack chat if you want to keep your homework response private, which I don't recommend, but you can keep it private. You can type it in my name in a one-on-one window.
Yeah.
If you want to keep it available to everybody, you type it in that group, 2017 Jan group, and that's where you submit your response. The homework here is basically describing and trying to understand whether you got the concept. The idea here in native versus web apps is something that I will describe when I get to that point.
Right.
You're welcome to proceed ahead and read. The whole content library is open. You can skip to any point in forward, backward, any order you like, and read and ask me questions because I have written down all of it myself. I know the thing left and right, so no issues there. And you can respond to anything, anywhere in all the 3 segments at any time, whatever, whenever you're reading, doing things.
Yeah, I just was wondering how you wanted to see it, but
yeah, it is, as I must have said, you don't focus too much on, making you do boring stuff. Let me put it right, put it very, very clear terms. I don't want you to get bored in answering. If you find that a homework is boring, I would say that you please don't do it. If you find that your homework is really silly, you should tell me, call out in public that, hey, Nilesh, your homework is silly. Because I don't want it to be silly. I don't want it to be boring. If homework feels like homework, don't do it. If homework feels like something you are really, really interested in doing and it is not enough, ask for it. I'll create new work for you. Right? I think we just timed out. So the idea is homework is something that you find interesting, you do that, and not anything else.
Okay. Thanks.
The timer, I just shut it off. So that answer to homework. So homework is anything that you find interesting. Anything else which is boring to you, don't do it. Don't have to do it. As simple as that. It is not a classic school, if you will, right? There is no exam here. You know that. You heard me before also.
Right.
I don't have an exam because I don't believe in it. I believe in making you individually successful, for which you have to work, and for which you have to build and do stuff. And you run into issues, I will help you. That's the idea. It's not about exams. It's not about getting a certificate. But yes, I will give you a certificate because by law I'm required to give you one. So I will give you. But that's not the point. The point is not certification. Point is not examination. Point is building, learning, doing, and creating an inventory of skills with supporting evidence that shows somebody that you have it. You got the skill. That's the core idea. And you will take that next logical step of whatever you want to accomplish in your career. That's the idea. Not exams, not silly homework. If homework is silly, don't do it. Thank you. Okay, next one. And by the way, if you find it silly, please tell me, so I'll remove it. I don't want to keep it then. Okay, next. This concept of virtualization is what I will be describing a little bit. Some of you know it already, so it might sound trivial, but I think it is worth going through it because it makes sense. Is that you saw me show you these pictures of rack servers. Right? You saw these pictures, and I will bring them up again. These pictures of servers in the rack. Like you've seen this. Like they look like this. These are actual physical computers, blades of one computer, like rack number 24, all the way from here to here. That's this rack. It spans across the width. That's a standardized rack in which a machine will fit. This machine in turn will have multiple processors, bunch of hard disk, no display card. There is no display here, by the way. So there is no display attached to it. You cannot see any user interface because there is none. There is none, absolutely no interface to see here. All of these are machines connected through some kind of a cabling on the backside that looks like this. And that's how you've seen these data center pictures, if not actual data centers. Now, under the hood, these racks, like for example, this one, there are three one on top of each other. These are individual computers, server computers. They will be something like this machine itself. It will have a processor, maybe a bunch of processors, some memory, some storage, some memory, like that. That's the core idea behind these racks, these rack servers. But what I'm going to describe now is this idea of a virtual machine. In this virtual machine that you have it running on your computers, you will see that this machine, specifically in my example, I have given this VM 8192 megabytes of memory. Where does this come from? It comes from this 32 allocation that we have here. This 32 GB that I have in the real machine, I have given 8 gigabytes to this unit that looks like this. That's what I've done. I have divided it. What does that boil down to? It looks like this. You have a physical computer and you divide it into 4 parts, for example. And here is 8 GB. The total was 32. And you allocate this memory to that Cloud Genius workstation. Let's call it the CG workstation. It gets 8 GB of RAM. That's the allocation that I did. This rest of the memory is available for my Macintosh. This is given away, so you use it. It's a partition. This concept of virtualization is not new. In fact, it is about 50 years old technology. Many of you were not born at that time. So long ago, there used to be a company called IBM, which had a machine called mainframe. That's where this concept came from. The large IBM mainframe computers were divided pretty much like this. And you could keep dividing until the smallest part you can get is still useful. It doesn't, you don't keep dividing it to the extent you can because it may not be useful. This has to remain useful. The smallest unit you can get that is still usable is the level at the depth at which you keep dividing a big machine. This concept used to be called logical partition, LPAR, LPAR. That was the name IBM used to use 50 years ago. And they have been using it even today. IBM's, they have renamed their systems as Z systems. They're the same mainframe systems. They're available even today. Many banks use it. The same idea is what is the foundation of virtualization. What I'm illustrating here in my example is out of the 32 gigs of RAM, I have given out 8 gigabytes of RAM to my VM, the Cloud Genius workstation. The one that I show you here. That machine, if you look at its settings, you will find that this machine has, how much RAM does it have? Details. And you will see that this machine has 7.8 GB bytes, which is about 8 gigabytes of RAM available to it. Now I was able to change it to 8 gigabytes because I can afford to give 8 out of 32. If your computer itself is 8 GB RAM, you cannot give it 8 GB to the VM. It's not possible. So by default, the setting is 2 GB. By most of you will have this setting, by the way, because that's what I have set. When I gave you the machine, I set it at 2 GB, so that's the default. Because not everybody has a large machine, so this doesn't make sense. So I shrunk it before I gave it to you. So that's the idea behind partitioning a machine. You make it smaller chunks. So in a real computer like this, you can divide and have multiple VMs. Like if I decide to have a 512 MB machine, I can have lots and lots of them running comfortably while have a video conference with you. No problem. I can arrange that. How do I do that? I'll basically take all my 32 gigs. I'll set aside some memory for my Zoom video conference and bunch of other things that I am running right now. And the rest I can allocate to a bunch of the virtual machines, maybe 10 or 15 or 20 or whatever number I can fit. I will have these machines individually run here, and they will all perform together collectively as a pool of virtual machines available to me in my physical machine. That's the underlying idea behind a virtual machine. A virtual machine, like you see here, this one, behaves just like a real computer. It can shut down properly, it can update itself. The only thing you cannot do is to physically touch it. I mean, it doesn't really exist, right? It's a file. You cannot go and touch this Scout Genius workstation. I cannot hold it in my hand, cannot do it. It doesn't exist, really. But it is a fully functional, completely functional machine that works just like a real computer. It is a virtual computer. It has everything that you would expect. It has, a CPU dedicated. Where is that CPU? Here, Intel Core. 2 of them actually dedicated, 2 cores. I've given it 2 cores, 2 CPUs given to this machine. I have 8, so I gave 2 to this. I have 32 gigs, so I have given 8 gigs to this. I have some hard disk. I have given it 132 GB of hard disk. The actual hard disk I have is these guys, but then 500 GB. So I have allocated 132 GB of hard disk to this machine. I can actually cheat and give it 2 terabytes of hard disk or even more, but I don't even have it. Do you know how to do that? Do you have an idea of what am I talking about? How do you cheat? You can construct a VM with 3 terabytes, but the real machine can be only 512 GB. Do you know how to do that? This is called, in simple language, fake allocation. It's a pretend allocation. The real allocation is not actually 3 terabytes, but you can do that, and I'll show you how. And that's the concept to understand that it is actually fake. And so I'm shutting down the VM, and I create a new VM, new machine for you right now. So here, new, and I'm going to give it a name. I'll call it Trump. Sorry for being political, but that's the machine. You can decide the operating system you want to fit in here. So I'll choose Linux. And this machine, I'll decide that I need to give it, say, that amount of RAM. Fine. I can give it a lot more RAM than this, and that's all green. If I go beyond this, it goes in the red area or orange area, and then I go really beyond, it goes in the red area. So I can allocate how much memory I want to give it. So this is good, fine. And I can go proceed forward and say that, you know what, create. So I'm creating a machine. I can then assign a 2 terabyte disk. I don't even have that much, but I can totally allocate 2 terabytes of disk. And here, I'm saying that I'm going to dynamically allocate. That's the keyword to remember, dynamic allocation. Actual allocation is not going to be 2 terabyte because it doesn't even have that room. I don't have that hard disk, that big a hard disk. My hard disk is 512 GB, but I can allocate 2 terabytes because it is dynamically allocated. It will be increasing in its size when you actually get to use it. And the moment you go beyond 512, it will crash. It's just a pretend game. It will crash because the actual physical disk is small. You're pretending it to be big, just like Trump. And so create. Did I crack that political joke? I did. Yeah. Sorry about that. I should skip those. But here is a machine. You have some 113, 11314 MB of RAM, video memory allocated, 2 terabytes allocated in the disk. But it's actually a small machine. It might look like big, but that's not the case. So you are basically now have 2 machines, one here and one here. You can have more. You can create any number of machines you like. And what I'm doing essentially is creating virtual machines, right? That's the concept. Now you can divide a underlying resource like CPU or your bandwidth allocated to your network. The network card you have, how much bandwidth you want to actually share with the virtual machine. You can, if you have this flat pipe, you can give a portion of that pipe, this portion available to the VM, and the rest of the bandwidth available to the real machine. You can allocate like this. You have 8 CPUs, you can allocate 1 or 2 to these guys, the virtual machine. You have RAM, you can allocate that RAM out of the 32 gigs of RAM that you have, you can allocate a portion of it, say 512 MB RAM, or even less, or even more, up to a certain reasonable limit. You can allocate RAM to that virtual machine and create such virtual machines as you go, as you feel like. And that is the underlying idea behind. You will have real machines like this, racked up like a rack machine that shows up in this picture, these pictures here. These are racks and racks of machines. But in every single such machine, you will have multiple virtual machines inside these machines. Multiple. How many can you fit in? Depends on how big the real one is. If the real one is actually big, you can fit in more VMs. If the real one is small, you will fit less VMs. What sizes of VMs? This company decides the sizes available are these sizes. So the biggest machine that you probably can get is this. What does that mean? It is a 64 GB, 20 CPU, 640 GB hard disk, 9 terabytes of data transfer. That's the biggest machine they will let you buy, or rent, I should say, rent, from this company called DigitalOcean. Let's go compare with Amazon. What do they give? What are the sizes that they offer? So if you select Amazon and see the sizes available, the smallest size you can get is a T2 Micro, actually T2 Nano, even smaller. T2 Nano is available with half a gig of RAM and some storage. And the biggest you can get are very large. It is like 32 processors, 244 GB of RAM, 800 GB SSDs, and 10 gigabit Ethernet. So really, really high end, but still a virtual machine. All of these are virtual machines. They're not real. If you want to get a real machine on the cloud, it's a different cloud, not this. For example, here, Packet.net. These guys give you real hardware, bare metal machines. Another company. So there are many such companies coming up. They give you direct access to machines. The full machine is yours, on the cloud, on demand, self-service, all the characteristics apply. This is just one example. Most companies like Amazon and Microsoft, and here we have Windows, Azure.com. This company will give you a account, which will basically be something similar to what Amazon does. So you get a machine, get a VM. These VMs will fit into a real machine somewhere in some fashion. You keep dividing and you get to the smallest part, which is still usable. That's the size you can see here at the very bottom, T2 Nano, or $5 droplet, like here, $5 per hour. That's the smallest that they give. It's still usable, but you can further divide, but it then doesn't make sense because it's not usable. So you want to remain useful, and you want to keep dividing until you stay useful and thereby reduce the price point. So the prices are low at smaller machine sizes. Prices are really, really low here in even smaller machines. The pricing on T2 Micro and for even smaller machines are really, really ridiculously low, so much so that they give you for free for 1 year. So that's the concept of virtualization. You're taking real computers like these guys and then virtualizing them to create fake machines. Just like our workstation here, this one. I mean, this virtual machine that I'm going to start again, this virtual box you have is a fake computer. You have it on your desktop. It runs. Very, very similarly, you can create a machine just like I did with the DigitalOcean thing. I created an account I created a machine and I logged onto it from here. There was no display. All I saw was this black window when I was able to connect to it. The idea is to be able to connect there, run our applications there, and then disconnect. Let the application run there. Whereas in the case of this workstation that you're looking at, the idea is to use this as our desktop to learn. This is not a machine where you run applications in the cloud, but it is more useful for us to practice. That's the primary idea behind this workstation. There's no other use case for it. Is to simplify our learning. That's the goal behind this workstation. It has preloaded all the content we need, and we will use this, but this is not a cloud computer. It is a virtual machine, but it's not a cloud computer. The cloud machines are available here, for example, or here, and there will be more examples as we play with. The core idea, as we will go back to our illustration, where is that? Here, is you have, let's say, multiple locations, like you saw in the case of DigitalOcean, or you will see in the case of Amazon. They have these multiple locations worldwide. Amazon has a Virginia location, Ohio location, Northern California, Oregon, Canada, Europe, 3 locations in Europe, 5 locations, 6 locations in Asia Pacific, and 1 in South America. Multiple locations where they have their own buildings. In these buildings, they will provide their cloud services. That's what they do essentially. Now, in each of these locations worldwide, so you have, say, this Seattle location, Oregon location, California location, and Canada location, East Coast Virginia location. So this is Virginia. This is your Oregon, for example. In each of these locations, for example, they will have multiple data centers, not just one, but multiple, and they will call them availability zone. They will call it availability zone 1A, 1B, 1C, like that, 1E, like that. They keep creating multiple availability zones for you to have independent locations that are fault tolerant. The idea is that they will create this building on one side of the river and this building on the other side of the river. So if something goes wrong here or there, the other one is probably not impacted. That's the hypothesis. And with that in mind, they will construct fault-tolerant zones for their cloud to be resilient. Now, in each of these availability zones, they will have a building, or maybe more than one building. And in that building, they will have multiple floors. And in those floors, they will have rooms. In those rooms, you will have racks and racks and racks. And these racks will have rack servers that look like, where is that? Where's that picture? Here, that look like this. And then inside of these racks are these servers, and these servers are then further subdivided into virtual machines. That's what you and I receive when we click that button here. Excuse me. Excuse me. When we click that button here to get me a machine, like click here and then go here to create, that virtual machine is what we actually receive. We don't get access to the full rack or the full slot in a server, in a blade. We don't get that blade, the whole blade, but only a portion of it. How big is what you decide depending on how much you need and how much you want to pay. Excuse me. Okay. The idea here is you decide how much you need, how many you need, and you get virtual machines that are spread out somewhere, almost anonymously allocated to every user. So you don't exactly know which building, which floor, which rack, and which blade actually has your VM running? It is obscure, very difficult to find out. And even, Amazon or a Microsoft company employees will not be able to tell, because it is purposely anonymized as to where exactly your machine gets allocated. So you cannot pinpoint my machine runs in that rack, in this server, that location. You cannot do that. Even if you try, you cannot get to the point. By the way, no Amazon or Microsoft employee will let you into this location. You cannot physically go there. And even if you go, you cannot tell, because even they have no idea where the machine gets allocated, because it is randomized to begin with. So that's the concept of you receiving a resource in some cloud. And it is a virtual machine, as we discussed. It is a virtual. I hope this virtual concept is clear in terms of understanding what it means, what it boils down to in terms of it's a fake computer. It works like real one, though. I think that part is clear. If there are any questions on a VM concept, let us understand. But let's understand and answer those questions if you have any. But it is a fake computer. It is a virtual computer. It is not real. You cannot go touch it because it doesn't exist. It's a file. And if you really look at carefully where the file is, it's that OVA file that I gave you. Right? If you look at this file here, that's the file that gets expanded. This file gets expanded and blows up into, it looks like here. And so our Cloud Genius workstation has a bunch of files that look like this. And it has the disk that looks like this, and the box itself looks like this, some previous snapshots and some log files and some other snapshots. That's what it boils down to from an actual running workstation. Will look like a set of files in this location. If you look at the new machine I created called Trump, you click on it, it has these three items. There is a VDI disk, there's the machine definition, and a previous timestamp. If you right click on this file and try to open it up in an editor, you can totally do that, by the way. Let's go see and do it to read and understand what that file contains. So if you look at that file called the trump.vbox, let's go open it in an editor. Here it is. See what it contains. It contains definition. It defines the machine itself. It says, let me make it a little bit different editor so you can see what's inside much better. So try this editor instead. Okay, so here I can point out much better in that here you can see that the machine itself has a unique identifier, this ID. It has some CPU allocated, some physical address extensions enabled false. The CPU's memory size is allocated 11314. The pointing device is a USB tablet, which is what I'm using right now. You can see it in my hand. The video RAM size is 16. It has these slots. This 1, 2, 3, 4, 5, 6 slots. There is some audio device. There is a storage controller. That is a PIIX4 type storage controller. There is a SATA hard disk. It's a hard disk of the type IDE. It is bootable true. And so that's how you will boot. And that's the kind of idea behind this particular machine definition. If you look at the disk itself, that is going to be a very big file. So it is not going to open in this editor. However, the definition of the box is a very simple one to read and understand. That's what I just did in that example that I opened up, is that these are basically files that appear to run like a computer because of a technology called virtualization. That technology is what is at the core of it. The technology comes from, let me show you what that thing is, where it comes from. It comes from this thing called VTX. It's a feature of the CPU. And here is the definition. It is called Intel Vanderpool technology, VTX, or AMD calls it something else, but both of them work very, very similarly. What they do is provide process isolation at the CPU level. This is the Core i7 CPU picture, and the CPU itself will carve out everything in a separate isolated segment in which you can then run an independent operating system all by itself. What does that translate to? that even if you have a underlying machine that is supposed to be running Mac OS Sierra, and you created a virtual machine, this is just the virtual hardware. It is hardware defined in the file I showed you. You still need to add an operating system. And the operating system I have decided to add in our Cloud Genius workstation happens to be Ubuntu operating system. Underlying operating system is Mac, but it is on the real hardware. This is virtual hardware that I carve out using the underlying virtualization capability of the machine itself, which gives me a smaller hardware on which I am responsible to install operating system. You can see that in here we have this operating system, but in this other machine called, where is that one? That I just created. This one is powered off. If I try to power it on, it will get stuck because it's no operating system found. So it says powered off, but how do you want me to boot? Which is the CD drive. So you want to give it a CD-ROM to boot an OS. You have to begin from that point. If you try to power it on, it will not start. Even if you attempt to it, it will get stuck. It says no bootable medium found, system halted, because there is no operating system here. The machine will not power on. You can kill it and say power off, but there is nothing else to do with it unless you add operating system. You have to add an OS. That is what is needed in any virtual machine or any physical machine that you buy raw. If you buy from IBM, Dell, Lenovo, those guys will add an operating system already and then sell it to you. But if you buy just the machine, you will get no operating system. You have to add it. You have to go to the operating system vendor, such as Ubuntu for Canonical. Ubuntu, you have to go to Canonical website, download the ISO file, burn it on a CD and boot from it to install the operating system on a new machine. Or you go to Microsoft and download that Windows ISO, or I think it is downloadable these days. Earlier, it used to be a CD-ROM, DVD-ROM that they will give you, and then you boot from that DVD, and then you install Windows. Or you can go to Mac, and the App Store you can download a package which will install in a Macintosh OS. So the idea is you have to begin from some source. That source needs to be official. Like here is the origin, the creator of this operating system called Canonical. Canonical is the company that makes this operating system. So they give it to you for free. It's an open source product. You download it from this website, and then you burn it on a CD, DVD, or USB, and here you go. Click the desktop, and you get the desktop download here, or you get to the server, and you get a server download here, or you want to get to the cloud, you can get a cloud download. But you know what? You don't actually download the cloud. You have it in the cloud already. You go to Amazon, they will give you the Ubuntu image right there. So you go EC2, and that Ubuntu image is already there for you to choose. There it is. And you select. That's all you do. So in that moment, you're actually installing the OS image on the machine that you create. You choose the size, you load an OS. That is what is expected of any new hardware that you receive for real. You are expected to install an OS, or the manufacturer will already add the OS for you. But when you get a new virtual hardware, you have to provide it an operating system, and you have to do it. You can add Windows, and yes, you can run a Windows on top of Macintosh just like this. And so here starts my Windows machine, and you can see it is starting up, and I can shut it down, do whatever I like, and at the same time, this machine is also running, by the way. And so there's no issues there. You can run Windows, and you can run Mac, and you can run Linux, all on top of this underlying machine, which happens to be a Mac. That Windows is starting up. Here it is. It is logging in. It will start in a minute. There it goes, started. So Windows started. I can go full screen if I like, and it becomes my Windows PC. And so that's the usage scenario. I can start, do whatever I want, and when I'm done, I can shut down the Windows machine just like that. But bottom line, underlying real hardware, you can construct multiple virtual machines. Each one of them needs an operating system. It's a VM. This is a real machine. It also needs real machine also needs an operating system. This is typically done by the person who's selling you the real machine. This you create your ADLET OS. That's the first step. If you create a VM in the cloud provider will give you an option to select the OS you want to be added, and boom, you get it. If you create a VM yourself, you have to provide that OS. Does that clarify as to what we are dealing with in terms of what we will be using in terms of understanding this VM business, right? Okay, good. Now, understand that this VM actually is a very use intensive, and I would say, what's the right word for it? I think the word is this, redundant. There is a lot of wastage that happens. It's very wasteful. The way of using virtual machines is actually wasteful, and I'll show you how. And we will then understand eventually in a couple of days, or maybe down the road, how does that waste is avoided? How do we avoid that wastage? So I'll point out these things. If I have a machine, a real one, and this real machine, assume that this real machine actually runs Linux. Let's imagine. Now I create a VM, another VM, and bunch of other VMs, and I want to run Linux. So I have to install Linux here and here and here. That you have it already here. Why not just use the underlying as opposed to installing it over and over? You're burdening this machine with another operating system layer that slows it down, and you basically wasting resource, right? You have the OS footprint, you're wasting storage here, you're making the VM itself slow. Why can't you figure out a method of using the underlying Linux itself? That is something that I would like you to remember, that this VM actually creates an overhead. And that can be taxing. It is expensive. Expensive as in terms of CPU cost. Not money, but CPU expensive. It is resource expensive. So that's wasteful. I want you to remember that VMs are generally wasteful. But we don't have a better option up until now. So we have been comfortably using that, doing that waste and just living with it. These days, there is a newer option. It's called container technology. And we'll talk about it, we use it. It's the Docker example, by the way, is a more efficient way of dealing with this problem. It actually avoids that wastage. So we'll talk about it later, not right now. But I want you to remember that virtualization is the concept that I'm discussing right now. And a different method is called containerization, is what we will discuss later. But I want you to be aware that this is kind of wasteful, because if the redundancy is what cuts, I don't like the waste part. But again, it's a model that we have been using it for many, many years. It works. And the benefit here is that you can actually, on top of a Mac, you can run Windows, you can run Linux, you can run other operating systems, and all of them separate, isolated, no problem. Whereas in containers, you cannot do that, because you have to have Linux and Linux and Linux everywhere. And if it's only that same kernel underlying Linux, then containerization works. If it is Windows, no, not possible. We'll talk more about this, but I'm just giving you a rough picture about what this thing entails so that you at least start to think in that direction. Okay, couple more things about virtualization. The idea about virtualization is
one question.
Yes.
If you scroll up a little bit on that container system,
yeah,
does it mean that every container which is there has to use the same version of Linux, right? There's no option to choose something else.
I would say same kernel.
Same kernel. Okay, got it.
You can use Red Hat and Ubuntu and SUSE and whatever, God knows. Mix and match, no problem. Kernel has to be the same. Yep. So virtualization, couple of subtleties. The benefits that I would like to point out and how it plays out in real life. The real usage scenarios are that it gives you isolation. Isolation as in, you have your computers, all of you have it, right? You have a Windows or PC or Mac or something like that. And you have this Cloud Genius workstation, which is a Linux machine running on top of your physical computer, which may be the real one that you have. You make a mess here, like, for example, you make a mess here. This is the mess that you create. This mess is not going to disturb your real computer at all because it is completely isolated. You can delete this one, no problem. And you can create another one and do more mess. You're welcome, no problem. And you can go back in time, forward, keep creating new mistakes, all of that, whatever you feel like doing, including destroying yourself. The self-destruction commands you can run comfortably. It is not going to disturb the real thing. It is safe. That's the kind of isolation that you get by using virtual machines. And it is pretty powerful, pretty useful. That's the reason why people use it. The fundamental reason why people use it is gives you complete isolation. And you can keep doing mess if you like. The other benefits are that it gives you some savings, cost savings. I think I've changed my color. So some cost savings come into play. And where do they come from? Let's go see. If I have a location where I have like a bunch of physical real machines here, real, 3 of them. And I'm running application 1 here, application number 2, application number 3. And my CPU consumption is 10%. In my CPU consumption here is like 30%. The CPU consumption here is like 50%. So now, that's the usage. And this is the usage. And this is the usage of these 3 applications, 1, 2, and 3. And I have spent same amount of money on these 3 units. I am kind of sort of wasting money by overspending here. Somewhere I should say, this area is kind of overspent. I unnecessarily spent money on a big box where I actually needed a small one. Same here. And same kind of sort of here. Like maybe I can justify that this is a good usage, maybe not. But the idea is I'm wasteful here. And so I want to avoid that wastage. And I can enable that by putting these 3 applications in independent virtual machines, pretty much like this. Get one box, the same that we had before. Create 3 VMs. One of the size of say 15%, another of the size of say something like 60%, and fit in the 10% consumption machine, application number 1 here, application number 2 here, application number 3 here. And I will have better overall utilization and still have some leftover capacity here. So I can utilize my expenditure on the equipment much more efficiently if I am able to compact multiple applications like these, 1, 2, and 3, in one box. Server consolidation, that's the idea. People talk about server consolidation. This is what's going on. Put applications together on one physical machine, put them together to optimize usage of resource. That's the classic example of why it makes sense to utilize virtualization to consolidate servers. People call this in a variety of names. They will say, we are using VMware, we are using OpenStack. Bring your name for it. Bring your technology provider. But underlying idea is that you are improving your overall utilization numbers for your equipment, and thereby saving. You don't have to spend on this, don't have to spend on this. All you need to spend is some money on the VM technology that you install on the underlying machine, and you can fit 1, 2, and 3, all the 3 applications on the same box, and they will all comfortably be able to succeed and survive and thrive with the consumption metrics that are the requirements of those 3 applications, and you still save money. Why not? Bring it on. That's the reason why virtualization started to begin with, is it saves you money. But I just said it is kind of wasteful, but yeah, that's the trade-off. So it is wasteful, but it's useful. And so it's older technology, so newer technology is coming up and getting adopted and all that. There are pros and cons, but certain cases we have to have. When we have to have an operating system which is not Linux, we have to use VMs. It is not possible to run a Windows application in a Docker container today. Maybe I should say it is not possible to run Windows application in Docker containers yesterday, because Microsoft has come out with a Docker container solution today, maybe 3 days ago. But yeah, it's still the development. It's coming out. It's called Azure Container Service. It just came out, I think, last month, Azure Container Service. And they will run Windows in Docker containers. So that's coming up. Eventually, it will stabilize. It is available right now as a product, but it is preview. So yeah. And by the way, even in that Windows Docker, it has to be all Windows. So you cannot run, if it is Windows here, then you can run container C1, C2, C3, like that. All of them have to be Windows. You cannot put Linux here. That's not allowed. It has to be the same. That's another challenge. And so it's a developing technology from Windows perspective, from Linux perspective. It is nicely done. All of let me show you a statistic here. Google runs 2 billion containers every week. That's the news in 2014. They start, everything in Google runs in a container, and they start containers 2 billion times a week. And this is not a joke. This is true. It's happening. Many companies are doing it because they know how to do it. They're doing it already for quite a while. They have built new technologies to help that, to support that. Larger companies are doing it. Newer companies are making use of it. Smaller companies enjoy using it. All of that. And so we will play with that technology as well. But for right now, I wanted to make sure that I help you understand this aspect of virtualization, which I think I did. And I welcome questions on this aspect of virtualization, which is, by the way, described here in the segment here. You should be able to read that. And questions? Anybody? Nobody? Okay. So you're welcome. By the way, you don't have to ask questions right away. You can always ask questions anytime. I'm open on chat all the time. If you want to talk face to face, you're welcome. Just type in. I'll tell you how to start a Zoom conference, even if you don't have that meeting number. Just type in /Zoom in the Slack chat channel like this. Don't act on it, but I just did. I just demonstrated. All I typed was /ZOOM, and it starts a meeting for you. It is open. You can just, even among yourself, if you want to chat, you can do it like this. Come on Slack chat, like /Zoom, and it starts a meeting for you. Just click on it and join. And you can talk, and it's open.
Hi, Nilesh. I have a question.
Yes, hi.
I just got an email today. It's talking about the next revolution in cloud computing called the serverless technology. I think it talks about AWS Lambda and all those stuff.
Yes. Very good one.
Is it close to containers, or is it even different than containers?
I'll try to answer that. But first of all, what Shiva is saying is this idea of serverless computing. What does that mean? So I will demonstrate that, and then I will demonstrate a small example, and then I'll describe what this serverless thing is actually. It is a new product coming out from Google, Microsoft, and Amazon. And all it requires is no server needed. You just run your application. That's it. That's the idea, which is kind of hard to understand. So I'll demonstrate first. Let's see. Here, go to this, where is that? Here, DigitalOcean, right? You click and you get a machine. What's the promise from DigitalOcean? Let's see the promise. The promise, oh, no, sorry, DigitalOcean. The promise is lightning fast machines available in 55 seconds or less. That's the promise, I think, if I remember right. Maybe they changed it. But the bottom line is you start a machine, you get a machine in 55 seconds, right? You saw that kind of sort of like about a minute, you had a new machine ready for you. That's the VM scenario. You start a VM, takes you 1 minute, sometimes more. If it is Microsoft, it will take longer. If it is Linux, it is going to go faster. And about a minute or two, you have a machine. You can start one machine and stop it and all that. That's the kind of time frame we are working with. Now I will demonstrate this idea of a container. So here we go. So I'm running a container, and I just I'm going to run it again. By the way, what I just did was I started a container and stopped it by the time you flicked your eyes. It already happened. I'll illustrate the point a little bit better. Here we go. Here, how much time did it take to start a new machine, which is running Linux? Less than half a second, less than a few microseconds actually. So I have a new machine running Linux in Docker. It took me microseconds. That's how quickly it starts and stops and starts again and stops again. Now, can you beat that? Do that in VM? No, not possible, right? Docker containers, you can start in like sub-second. Start and stop very, very efficiently. Now extend the same idea. Basically use the container technology to run one thing. Start something, do it, and then stop it. On demand, whenever you need to run something, and run that as a service. That is what serverless computing is. You're basically extending this idea of sub-second responses to start something and stop something very, very efficiently. And on demand, if you have to run a command or a backend service call, you initiate that, you initiate a new container, you put your code, you run that code, and then you're done with that execution, you terminate the container, and you are done with the concept of backend processing that you wanted to do. So that is the foundation behind serverless computing. It is evolving right now. You can see it called Lambda in Amazon here. If you go to Amazon, they will have a Lambda thing here. And so it is called, Google has this called Google Functions, is the name for Google technology. This is the documentation or the site for Google Functions. It is in alpha. Microsoft has also Microsoft Azure Functions or something like that. Azure Functions. So they also have a competing product, serverless architecture from Microsoft. The core idea essentially is that you see that the containers start and stop very, very efficiently. So you have a pool at the back end running whenever you need to. But when you're done, just terminate them, move on. And so you have a process that you're running, you need back end processing, you start any number of containers you like, you execute your thing, and the execution finishes, and then you kill them all. And that is what is, again, an illusion of being serverless. There is a server that runs Docker. It starts and stops so fast that you don't even have to worry about it. And on top, these companies are managing it for you. So you don't even have to manage your containers. All you do is write your functions or your procedures or your function calls like here. You read the documentation if you like. Or where is that Lambda? Here, You write a lambda function, and you define a blank function. You write your code in that function. You basically write just the code. That's all you do. And you execute the code, and it will in turn execute a container operation. It starts a container, runs the code, shuts down the container after the execution is finished. And then you think that it is serverless, but it is not. But that's the branding. That's the way they're describing. All these companies are talking about serverless computing.
So Nilesh, this is Sami. So you are saying that the serverless terminology, like when it's container versus VM, they are calling it serverless?
No.
Basically.
No.
Or did I get it? Yeah.
No, I'll describe. There are three distinct things. One of them is VM. In Amazon language, they call it EC2. In container land, Amazon has the word, they call it ECS. And they have created a third product called Lambda, which they are calling it serverless. The underlying execution method actually uses container technology.
Here's what I found on the web for mixing politics.
And here EC2 actually is Elastic Compute Cloud, ECC, to be precise. Elastic Container Service for containers. Elastic Compute Cloud is for computation, virtual machines. And serverless is a branding that they are creating. Under the hood, this is also running containers.
So Nilesh, are basically all they're doing is keeping like a pool of like the lowest level of a cloud instance or VM instance ready for them to grab, and then it just expands to whatever they're trying to execute? Is that why it's making it so quick for them to run these executions?
So I think, I don't know exactly what they're running on the back end. All I read from what's available is that they have containers running directly on bare metal. Whenever you demand, the Lambda function demands execution, they will initiate a container on the bare metal machines that they will have a pool of. They will have a large pool of bare metal machines running in the back end. They will not run your container, but initiate a container using the function that you want to run that function, and then relinquish the container. This bare metal cluster of machines will keep on running. That's where they will provide this serverless service. It's a compute as a service, if you will, as opposed to infrastructure as a service here, or container as a service here. This is your computation as a service. So they will let you do your computation of your functions that you want to call, and that will execute on some container somewhere on the back end, which will be a pool of bare metal machines on the backside. It will run it for you. It will not charge you for the container you create, but only for the execution time you use. So the Lambda pricing, let's go read that. Lambda pricing is, let's go here and read. The pricing is here. First 1 million requests per month are free. So you request for something to happen, first million requests free every month. 0.2, 20 cents per million requests thereafter. So you want to execute something, on every request basis, you pay them 000, God knows what that number of zeros, 2 per request. That's the pricing model. It is very, very affordable. But again, if you have billions of transactions, billions of requests happening, that can get really expensive. Really expensive.
So what kind of applications, Nilesh, can you give us an example, which would probably be?
Here we go. Let's go Lambda usage. Example. Or rather, sites using Lambda. And pull it up. Here is one example. This company is called airpair.com. What they do is, let's see if I have a login here. And so log in with GitHub, and okay, I need to sign in. And there we go. So here I'm authorizing my application. The idea would be that this company, AirPair, will enable, hold on. I think I must have chosen the wrong company, the wrong example. Go back here. It's a blog article about how to do it, not an example implementation. So let's go back. And who uses Lambda? Sites using Lambda. WordPress theme, architecture. Yeah, here is probably one example. Here at Fuge, the team is small, but they like JavaScript. And let's see what they are doing. So get Fuge. So fuge.co, fuguv.co. And that's one example of it. It's an evolving, so radically simple cloud operations. Build, enforce, and terminate your cloud workloads at scale continuously and automatically. You get Fuge. So you basically create your application, give it to them. The idea would be that they will execute it for you. You pay as you go on execution. The usage models, I'll come up with specific companies that actually have used Lambda as a service. And there are not many, by the way, but there are some that have actually put this to production usage. And I'll give you a link. I'll find out and give you that link as to who's using this idea. Underlying technology is still containers, because they can actually put a bunch of containers here on the bare metal and provide it as a shared pool of resources to people using Lambda. That's the concept. It is definitely the evolution that will happen eventually. It is usable today. I have used it. It works, and I will. Go ahead.
Question?
Yes.
This is Sami. So how do they do the isolation in a serverless capability?
Yeah, the isolation happens by the fact that a container itself is isolated from another container. So this is C1, this is C2, and the isolation will go something like this. Let me create two containers right now. Hold on. So here in this window, let me hide the other windows here. So click, 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 and here is one window I have running. I'm going to run this Ubuntu here, and now another window, and I'm going to run another Ubuntu here, right? I have two containers running, one in this window and one in the other window. So let's go make it a little smaller. So I have one window on the left, one on the right. Let's go see this. I have some files here. So I am going to go to the home folder, and in there I will see that I have nothing. So I'll create a file called test.txt, and I will go to the same thing here and go to the home folder, and I'll find that I don't have anything here. So it's two different machines, two different containers right there. I created a file called test here that shows up in this location, but in this, it's a different container. The container ID is different. Here the container ID is 44 Delta 26. Here the container ID is 38143. So two distinctly separate containers running on the same underlying infrastructure here. I have set up Docker, that's why it runs. Otherwise, on a Mac, you cannot run Docker unless you have installed it. So the bottom line is containers, like you can create any number of them you like, and they are all independent of each other. So isolation, when it comes to this request, a bunch of requests all running on it's a bare metal pool of resources, so pool of machines, all have the capability to run containers. When multiple customers will ask for their Lambda function to be executed, the idea would be to instantiate separate container for every function, and then run like this. A function runs here, another function runs here, another one runs here. And by the way, you will see that if I go to the home location and list out, there is nothing here. If I go here, home, and list out, there is nothing here. And I will do some destructive operations. For example, let's say I have this bin folder, for example, here, right? I like that bin very much. So I'm going to be silly and rm-rf/bin. Should I do that? Most people will say, no, don't do that. But I am going to be okay. Why? Here we go. I just did that. I just shot myself in the foot, and that's okay because it's only that container got destroyed, right? This machine is totally fine. It still has the bin folder right there, and so is this. Where am I? PWD root. Yeah, my bin folder is intact there, right here. Where is bin? Yeah, there. In here, nothing will run because the bash command called ls is dead. I shot myself in the foot in this container, but that doesn't bother me because all other machines, all other containers are just functioning fine. See, that bin is still intact. I don't care about this container because I can just quit it and create another one, and I'm okay. I'm okay. So it is totally isolated. That's the bottom line. Bare metal pool of containers running on demand on basic Lambda function calls are totally isolated from each other. And even if one person shoots themselves in the foot, no issues. Does that answer your question?
So, Nilesh, those bare metal pool of servers, are they exclusively only used for the Lambda firing up? I mean, the Lambda functions, or they're also used for the ECS and the ECC?
So let me say this. I do not know exactly what they're doing because they don't tell us.
Okay.
But I am betting money that that is what they will do. They will allocate a set of hardware, bare metal machines for the Lambda as a service that they are offering, which is separate from any other service. They will have other things that they do. There are a bunch of huge number of things that they do. And so for Lambda, they will allocate some pool. Depending on how much people are hitting that service, they'll add more hardware over time. But right now, it's probably small. I don't know how big they are. Maybe we can read on their website and ask them if you like. But the point is, it's a service and it's a decent one. I think it is useful. So it's the evolution. You will see that evolution happening in this direction. VMs to containers to serverless. That will happen. Absolutely.
So does it mean that they can the Lambda service can still run Windows machines or something like that, or it can only run commands or functions?
So Lambda, the idea behind Lambda and these Google functions and Windows functions, Azure functions, is the idea is to execute your code. Now your code requires underlying operating system dependency, then you have to use a specific type of service, such as if you have a .NET thing, you have to run the Azure Lambda or the Azure function. If you are using JavaScript, you can run anywhere you like because it runs everywhere. It's the underlying language that you have. If it is limited to .NET C#, you will use the Azure functions thing. But if you have, let's see, here they have a C# solution here. You can see that they have a JavaScript, PHP, C# solution. This is Azure, by the way, Azure functions. If you look at Google, they will have function support for JavaScript and where is the language support? Documentation will give us that language support. They will probably support Python, Java, and JavaScript. That's the Google way of doing things. In Amazon, I think they support Lambda support languages. So let's go see. Lambda languages are product detail. The languages are how it works with the language listing. Okay, they don't describe the language. I think they support all of them except .NET. I'm not sure though. I'll check the language support. But the core idea is you don't have servers to manage. It scales for you, sub-second pricing, sub-second metering, and you upload your code to a storage location and it gets invoked and you just get the execution outcome, and that's all. That's all it takes. Sweet. So what I want to do, I think we are across the hour. So the website, I think the next time we meet, we are meeting on Thursday at 4 o'clock Pacific time, which is translating to 7 o'clock Eastern time. And that day is 19th. 19th of January, Thursday at 4 p.m. Pacific, 7 p.m. Eastern is when we meet. In the meanwhile, I suggest that you please review this content and try to go forward as much as you can as you proceed. There are certain things that I have skipped today. You may notice that I skipped on native apps and web apps. So that discussion I skipped, but it is here for you to read. There are some other things, but we will start on the module number 6 when we begin the next time we meet, which is Thursday, 19th of January, right? So I want to ask you a last question. Thumbs up or thumbs down? How did we do today? Was it useful? Was it boring? Was it interesting? Tell me.
I thought it was great.
Yeah, I thought it was good.
Awesome. Thank you. Keep feedback coming. I welcome feedback. Thumbs down is okay. Totally okay. In my face, in front of everybody is also okay. I don't care. I want to hear. I want to hear if it is not good. Please tell me. Because if I don't improve, the company will die. Honestly. That's
Yeah,
how
this was good because it's right in line with what we're all seeing and hearing. So this is great.
Thank you. Thank you for saying that. I will, if you want something to be covered that I may not have or may not have planned, I will include that. Please type about it, talk to me, tell me, email me. I will include that. If you want something covered that I do not have in the coverage in our documentation in the website, please tell me. I will do that. I promise. If I cannot find a solution, I will work towards finding a solution. So with that, I'll see you guys tomorrow. The Slack chat is active. For those of you who do not yet have the Cloud Genius email and you want it, there is no reason, absolutely no reason to get that Cloud Genius email, by the way. No reason, except there are a couple. Like for example, if you want unlimited storage for free, for life, you should get it. I think some of you have access to that hard storage from Google. Google gives you free storage in Google Drive, unlimited. And if you want more, I can give you 2 times unlimited. Yes, you can laugh. But if you want that, stay online. And some of you have it. If you don't want it, don't have to use it. There is no requirement. You can keep using your email, whatever you like, you do that. But if you want a Cloud Genius email, it comes with Office 365 solution sets, Google Suite, and Facebook for Workplace, which we just got like 3 or 4 days ago. I don't know what to do with it, but I have it. If you want it, I give it to you. So for those of you who want a Cloud Genius email, please hang on to the video conference. I will now start giving you your passwords that you can reset. The steps will be that I will give you your password individually in a one-on-one chat. You will go to this location to reset your password. And then you will change your password. Then you go access Office 365 services on that location. After that, you will go log into your Google services in this location. And then you will log on to this location if you are interested in that Facebook thing. But none of this is required. Absolutely none of it is required. Don't have to get it. But if you want it, stay online. So here, cloudgenius.facebook.com. That's another one. And then the Google Drive unlimited storage is available in this location, drive.google.com. That's where you get it. So I will now, one by one, give you your email address, the Cloud Genius email, and your password will be in your one-on-one chat. Beginning with, okay, volunteer please. Who wants it first? I have it for everybody, but Siva. Okay, Shiva.
I'm going to sign out. I have other things to do right now.
Yeah, go ahead. You feel free to hang up. Bye-bye.
Thanks for the time.
Yeah, bye-bye. See you the next time. So here we go. I'm going to reset the password for Shiv, and let's do that. So logging in. And I'm looking for Shiv. There it is. And so Shiv, your password will be, I'm resetting it. Here it is. Here is your password. You should change it. And that is the password, which I'll paste in a one-on-one chat for you. It is in Slack chat, and here it comes. And you should follow along with the other steps. And I will now enable your Google authorization. So I will do that part while you log on and reset your password. I will go fix the Google authentication piece.
Okay.
And then the next one, the Facebook authentication. So I'm basically doing a what is known as a single sign-on method, and that is what I am enabling right now. So you should be able to reset your password by now, and it will let you access Office 365 services already. And after that, I will tell you to go to the Gmail account. If you want to share your screen, you're welcome to do that. So I can guide you if you like.
Okay.
So if you want to share your desktop, you can.
Okay.
And once you do that, I should be able to help you reset the.
Yeah.
So click the green button at the bottom, and then, yeah, there we go.
Okay.
Now here you go to portal.office.com link, the first link I gave you in chat.
Okay.
That should be in Slack chat. So in the group chat.
No group chat. Okay.
And you should install the Slack application also. So go to portal.office.com, the first link, and that's where you change your password. And then your email address is, you know that?
Yeah. No.
No? Okay, hold on. Your email address is shiv@cloudgenius.
Okay.
Let me confirm that. I think so. Yeah, shiv@cloudgenius.
Oh,
With
that's
a
it?
dot,
Okay.
dot before the US.
Oh, yeah.
Yeah, and the password, you have it already. It'll ask you to change it, so don't save this one.
Okay.
It'll make you change it. So back to the.
Okay, Nilesh, I'm done with that.
Okay, now click on the Gmail link and that will open up your second. So you have, through this, you have access to Office 365 service,
Okay.
right? You select your time zone and
Okay, so that's done.
yep. And then go to Gmail. And I should also stop this recording. I don't know why we are recording the remainder. We don't
Okay.
record this. I'm going to stop recording. Hold on. The recording button. There we go.
Okay, so go back to the.
Yeah, hold on. Let me just stop recording. Otherwise, the recording file becomes big for no reason. Hold on. There we go. Stopping the recording now.